Beyond the orbit of Neptune, where sunlight fades to a pale echo and the solar wind thins to a cosmic sigh, two tiny machines drift through forever. Voyager 1 and 2, emissaries of our species, still whisper across the void after nearly half a century. Yet, what they've seen in the dark beyond Pluto isn't silence. It's something far stranger. Tonight, we follow their path to the edge of everything. Like and subscribe. If you enjoy the journey, it truly helps us continue exploring together. Now, close your eyes. Let's begin. In 1977, humanity launched a message in a bottle, a golden disc engraved with the sounds and images of our world. But few realized that this gesture wasn't just symbolic, it was a promise, a declaration that even in the infinite dark, someone or something might one day listen. The golden record was humanity's love letter to the cosmos, a time capsule crafted with both science and poetry. On its shimmering surface, etched into copper and coated in gold, were 115 images, 90 minutes of music, greetings in 55 languages, and the sound of a heartbeat. It carried the laughter of children, the hum of ocean waves, the cry of a baby, and the whisper of wind through trees. To any who might find it, it said, "This is what it feels like to be alive on Earth." Every groove of that record was a deliberate choice, a moment of humanity distilled into sound. Carl Sagan and his team at Cornell University curated it with reverence, not as a catalogue of achievements, but as a portrait of emotion. The music ranged from Bach to Blind Willie Johnson, from Navajo chants to a field recording of thunder in the Amazon. It was an archive of awe. If the stars had ears, this was what we wanted them to hear. The disc itself was built to endure 1 billion years, a fragile yet immortal artifact. On its cover were engraved symbols, a pulsar map pointing to Earth, instructions on how to play it, and a visual explanation of the record's rotation speed. The engraving was more than design, it was translation, a universal language written in the mathematics of the cosmos. And yet, perhaps the most moving part of all was the human touch. Etched on the record's protective cover are the silhouettes of a man and a woman, standing beside the outline of the spacecraft, anonymous yet deeply familiar. They are not kings, not soldiers, not scientists. They are simply us, unarmed, open, reaching. The record's journey began at Cape Canaveral, aboard Voyager 1 and 2. Two golden discs carried by two silent messengers, flung toward the edge of the solar system. At the moment of launch, they were nothing more than tiny machines. But as they left the warmth of the sun and drifted into the cold, their cargo took on a deeper meaning. Humanity had just spoken its first word into the void. By 1980, the Voyagers had photographed the gas giants, revealing moons, storms, and rings no human eye had ever seen. But to many of those who built them, the greatest image they carried wasn't captured by a camera, it was pressed into that record. A reflection of Earth as it once was, alive, young, hopeful. Now, nearly 5 decades later, those golden discs still drift silently through the interstellar dark, untouched, unseen, uncorrupted by time. They will outlive our cities, our languages, even our species. Someday, perhaps 1 billion years from now, someone may find them, turn them in their hands, and press play. And when they do, they'll hear the voice of a mother, the rush of rain, the hum of wind, and the distant heartbeat of a small blue world that once dared to say hello. Because that's what the golden record truly was, not a message of discovery, but of belonging. A quiet whisper to the cosmos. We were here. We dreamed. And we wanted to be known. Voyager 1 and Voyager 2 are not just spacecraft, they're twins born of the same dream. Launched weeks apart, their missions diverged like two souls travelling different paths, one toward Jupiter and Saturn, the other toward Uranus and Neptune, before vanishing into the black. They were built in an era when humanity was still learning how to touch the stars. Each Voyager weighed less than a small car, but carried within it the most advanced technology of its time, computers with less memory than a digital watch, yet capable of navigating billions of miles through empty space. Their creation was an act of optimism, a belief that curiosity could reach farther than fear. When engineers at NASA's Jet Propulsion Laboratory assembled them, they knew they were building something more than machines. They were building endurance. The two Voyagers were nearly identical. Each carried the same suite of instruments: magnetometers, plasma detectors, cosmic ray sensors, cameras, and of course, the golden record. But like all twins, they developed their own destinies. Voyager 2, launched first, would take the longer, slower path, the grand tour that would visit all four of the gas giants. Voyager 1, launched second, took a faster, steeper trajectory, designed to sling past Jupiter and Saturn, then escape the solar system entirely. Together, they formed a kind of celestial symmetry, one staying to see more, the other racing ahead to go farther. When the Voyagers first lifted off from Cape Canaveral, they were carried by the same kind of rocket that once took humans to the moon. As the Saturn V's younger cousin roared to life, the ground shook with a thunder that could be heard miles away. Those watching understood they were witnessing history, but they could not have imagined that half a century later, those same machines would still be speaking. Voyager 2 was the artist of the pair, pausing to admire the outer worlds in detail. It painted Neptune in blue, discovered volcanic eruptions on Io, and saw Saturn's rings shimmer in sunlight. It was the explorer who couldn't resist stopping to gaze. Voyager 1 was the runner, relentless, urgent, carrying the flame into the unknown. After Saturn, it didn't look back. Its path was set for interstellar space, toward the stars beyond our sun's reach. The bond between the two craft is almost poetic. Even though they travel in different directions, they remain connected through their transmissions, like long-distance siblings whispering through the dark. Every signal that returns to Earth takes over 20 hours to arrive, crossing billions of kilometers through the cosmic ocean. By the time the data reaches NASA's Deep Space Network, the Earth has already spun beneath them. It is a conversation across time itself. What's remarkable is how little they needed to endure forever. Their power comes from tiny plutonium cores, slowly decaying, releasing warmth that keeps their instruments alive. No solar panels, no batteries, just the faint glow of physics itself, sustaining them against the cold of interstellar night. As of today, Voyager 1 is more than 15 billion miles from Earth, the most distant object humanity has ever created. Voyager 2 follows behind, still whispering faint signals home. Together, they represent something deeply human, not conquest but curiosity. Two small emissaries, carrying the dreams of an entire species, leaving footprints where there is no ground. And perhaps that's the beauty of their story. They were not sent to find life or to return treasure. They were sent simply to see, to look into the darkness and report what it found. Twins born of the same dream, separated by distance, united by purpose, still traveling, still reaching, still saying, in their quiet rhythmic signals through the void, "We are still here." This rare planetary alignment happens only once every 176 years. It allowed the Voyagers to slingshot from one giant world to another, using gravity's pull. Like cosmic surfers, they rode the invisible waves of space-time, saving decades of travel and revealing worlds we'd never seen before. It was a celestial choreography, written long before humanity learned to look up. 4 giant planets, Jupiter, Saturn, Uranus, and Neptune, arranged themselves in a perfect arc, their orbits aligned in a way that happens perhaps twice in a millennium. For most of history, this alignment would have gone unnoticed, but in the 1,970 seconds, engineers realized it offered a window, a gravitational highway across the outer solar system. If a spacecraft could catch the first wave, Jupiter's immense gravity could fling it towards Saturn, Saturn could sling it to Uranus, and so on, carrying it outward like a stone skipping across a cosmic pond. The mathematics were staggering. Each slingshot would not only accelerate the spacecraft, but bend its path, allowing it to visit multiple worlds on a single journey. Without this alignment, reaching Neptune would have taken centuries. With it, Voyager 2 could do it in just 12 years. The Grand Tour was not just a mission, it was an opportunity that comes once in a human lifetime, and if missed, would not return until the 22nd century. The plan was as audacious as it was beautiful. NASA's engineers plotted a trajectory that used the natural gravity of the planets as engines, each one boosting the spacecraft to its next destination. It was a ballet of precision, where a deviation of even a few seconds could send the Voyagers drifting forever into the dark. The timing had to be perfect. The math, flawless. When Voyager 2 first approached Jupiter in 1979, the maneuver worked exactly as intended. The planet's gravity grabbed the spacecraft and hurled it towards Saturn at 38,000 miles per hour. But the slingshot wasn't just mechanical, it was also emotional. For the first time, humanity could look down upon the swirling clouds of Jupiter, its lightning storms illuminating the night side, its moons glowing like ancient lanterns in orbit. Each image sent back was a window into a realm we had only dreamed of. By the time Voyager 1 reached Saturn, the technique had become an art form. Engineers used the planet's pull to fine-tune its path, sending it on a trajectory that would carry it above the plane of the solar system, a view no human or machine had ever seen. From that vantage point, the rings of Saturn stretched like ripples across a cosmic lake. Voyager 2, taking the longer path, continued onward, first to Uranus, then Neptune, capturing glimpses of worlds that shimmered like frozen ghosts. Each gravity assist carried it deeper into the unknown, but also farther into history. Humanity had, for the first time, explored every outer planet, not through conquest but through harmony with nature's laws. The Grand Tour was not merely a feat of engineering, it was an act of cosmic humility. Rather than fighting against the universe, we let it carry us. The Voyagers became dancers in a vast celestial waltz, using the planets themselves as partners. They showed us that even the cold mechanics of physics can become poetry when touched by human intention. And as they left Neptune behind, gliding into the deep beyond the sun's light, the gravitational music faded into silence. The dance was over, but the echo of that movement, the elegance of riding the forces of the cosmos instead of defying them, remains one of humanity's most profound lessons. That sometimes, the best way to go farther is to simply let the universe guide you. When Voyager reached Jupiter, it saw the planet not as a stormy sphere, but as a living canvas. Lightning storms bigger than Earth, auroras rippling across the poles, and the Great Red Spot, a hurricane that's been raging for centuries. The images revealed a world that felt almost aware of being watched. It was 1979 when Voyager 1 arrived in Jupiter's kingdom, the largest, oldest planet in our solar system. What it found there was both terrifying and magnificent. Jupiter wasn't just a planet, it was an atmosphere without end, a roiling ocean of gas where colour, motion, and electricity blurred into one endless storm. The spacecraft captured images of clouds shaped like feathers, ribbons, and eyes, intricate swirls of ammonia and hydrogen that seemed to pulse with hidden intelligence. It was as if the planet was alive, breathing in convective patterns that stretched thousands of kilometers wide. For centuries, telescopes had shown us a distant orange orb banded in stripes. But Voyager's arrival transformed Jupiter from an abstract dot into a dynamic, evolving world. The Great Red Spot, that immense storm large enough to swallow Earth whole, revealed itself in motion, rotating counterclockwise with winds exceeding 400 miles per hour. Voyager's cameras saw it from above, not as a mark, but as an abyss, a vast rotating wound in the planet's skin, bordered by spiraling clouds that looked eerily like living tissue. Yet, Jupiter was more than storms. Voyager's instruments detected massive lightning bolts, electrical discharges hundreds of times more powerful than any on Earth. They flashed within the planet's deep cloud decks, illuminating layers of atmosphere that had never before been seen. These were not random sparks. They were the heartbeat of a planet that never sleeps. Then came the magnetosphere, Jupiter's invisible giant. Stretching millions of miles into space, it's the largest structure in the solar system. A magnetic field so strong it creates radiation belts deadly enough to destroy unprotected electronics. When Voyager entered that realm, its sensors lit up with data unlike anything engineers had ever seen. The spacecraft was literally flying through Jupiter's magnetic soul, a sea of charged particles that roared like invisible thunder. The radiation distorted the cameras, fried minor circuits, and left traces of static in the images. But even the damage told a story of power on a scale beyond comprehension. Perhaps the most haunting discoveries came from the planet's moons. Io, closest to Jupiter, was alive with volcanoes, the first active eruptions ever observed beyond Earth. Its surface glowed with sulfur and lava, painting a world constantly reborn through fire. Europa gleamed like a cracked mirror, its icy crust concealing what scientists now believe is a vast ocean beneath, a potential cradle for life. Ganymede and Callisto, ancient and cratered, orbited like silent witnesses around their immense parent. Each moon told a part of Jupiter's story: creation, destruction, and endurance. The planet itself acted like a miniature solar system, a world that births worlds, shaping its children through gravity and radiation. Voyager revealed that Jupiter was not just another stop on the Grand Tour, but a threshold, a place where the familiar laws of Earth began to dissolve into the alien. As Voyager passed behind the giant and looked back, it saw something extraordinary: auroras dancing at Jupiter's poles, vast ribbons of light created as charged particles funneled through the magnetic field. They shimmered in ghostly blues and greens, a cosmic ballet taking place in silence, visible only through instruments tuned to the invisible. When those images were transmitted home, the world stopped to look. For the first time, humanity saw Jupiter not as mythology, but as reality, a restless, colossal being, painted in color and motion. It wasn't merely a planet orbiting the sun, it was the first true glimpse into the deep personality of the cosmos, ancient, indifferent, but achingly beautiful. The rings of Saturn shimmered in Voyager's lenses like frozen music. Made of ice and dust, they spun in delicate harmonies around the planet, casting shadows that seemed to pulse in rhythm with the spacecraft's heartbeats. For the first time, we saw the structure of beauty written in orbit. When Voyager 1 arrived at Saturn in late 1980, humanity met the most elegant world in the solar system. From Earth, Saturn's rings had always appeared as smooth, solid bands, simple arcs of light. But as the spacecraft drew near, that illusion dissolved. Voyager revealed that the rings were not solid at all, but composed of countless particles, chunks of ice, grains of dust, fragments of rock, each one orbiting independently, yet together forming a perfect celestial symphony. Through the spacecraft's narrow-angle camera, the rings became a landscape. Some sections were dense and bright, others thin and nearly invisible. Tiny shepherd moons carved gaps through the ice, maintaining sharp edges and delicate patterns through their gravitational pull. It was like watching invisible hands sculpt the void. The Cassini division, the great dark gap between Saturn's main rings, was revealed not as emptiness, but as a tapestry of faint, braided strands. Each pattern hinted at motion, resonance, and mathematical precision so intricate that it felt almost intentional. As sunlight streamed through the icy debris, Voyager's sensors caught something miraculous: light scattering in different colors, revealing hidden structures within the rings. There were waves, ripples, even vertical cliffs made of ice particles rising hundreds of meters high. The rings were not static ornaments, they were alive, shifting with every orbit, responding to the gravitational dance of Saturn and its moons. The spacecraft's instruments detected that the rings were made mostly of water ice, some of it pure enough to rival Earth's snow. Each particle reflected sunlight like a tiny mirror, and together they created the soft silver halo that makes Saturn one of the most recognizable objects in the night sky. Yet, in the shadows, those same particles plunged the planet's atmosphere into darkness, creating bands of temperature and color that rippled like sound waves. Voyager also found that the rings sing. Deep within Saturn's magnetosphere, electromagnetic vibrations resonate through the charged particles in the rings, producing frequencies that can be converted into audible tones. When scientists translated the data into sound, it resembled a haunting chorus, ethereal, harmonious, yet unsettling. It was as if the planet itself was humming through its rings, a cosmic instrument strumming across the vacuum of space. And then there were the moons, Titan, Enceladus, Mimas, Dione, each playing its own part in Saturn's orbiting symphony. Titan, the largest, hid beneath a thick orange haze, its atmosphere denser than Earth's. Voyager's instruments pierced that veil, detecting methane, nitrogen, and complex organic molecules. It was the first hint that Titan might possess the chemistry of life, an echo of early Earth frozen in time. Voyager's flyby revealed a planet that seemed sculpted for beauty. Golden clouds swirled across its surface, storms cast long shadows over the rings, and sunlight glinted across miles of crystalline debris. As Voyager passed behind Saturn, the rings glowed from backlight, a luminous arc stretching across the blackness, brighter and more fragile than anything seen before. The images returned to Earth captured something beyond science, a kind of cosmic perfection. Saturn's rings became a metaphor for the universe itself. Chaos organized into order, motion woven into art. Each particle followed its own path, yet together they formed symmetry, resonance, and grace. As Voyager continued its journey outward, the rings faded into the distance, shrinking from a grand orchestra to a whisper of light. But their impression lingered, not just as data, but as a feeling, that even in the coldest reaches of space, nature composes beauty beyond our comprehension. Saturn wasn't simply a planet, it was a revelation that the universe doesn't just create matter and motion, it creates wonder. Voyager 2 alone would venture to Uranus, a pale turquoise world tipped on its side, rolling through space like a fallen marble. What it found there defied expectations. Magnetic fields twisted at impossible angles, and winds roaring faster than any storm on Earth. By the time Voyager 2 reached Uranus in January 1986, it had already travelled nearly 2 billion miles from the Sun. The spacecraft was operating on borrowed time, power reserves thinning, instruments aging, yet still whispering across the void. As it approached, the distant planet came into view. A smooth blue-green sphere, serene and silent, as if it had been painted in watercolour. But beneath that calm surface, something astonishing was waiting. Uranus is unlike any other planet in our solar system. Its axis is tilted by 98 degrees. It doesn't spin upright like Earth or Jupiter, but sideways, rolling around the Sun like a wheel. For half its year, one pole faces constant daylight, while the other lies in endless night. This bizarre geometry gives Uranus its strange seasons, each lasting more than 20 Earth years. The planet's weather patterns, sunlight distribution, and even its magnetic field are all warped by this cosmic tumble. Voyager's cameras revealed a world of eerie minimalism. Unlike the vibrant storms of Jupiter or the majestic rings of Saturn, Uranus appeared blank, a pale cyan void. But the instruments told a deeper story. Hidden beneath those clouds were winds reaching up to 900 kilometers per hour, sweeping the atmosphere in ghostly, invisible ribbons. Voyager detected vast jet streams circling the planet's equator, driven not by sunlight, which is faint at that distance, but by heat escaping from deep within the planet itself. Then came the surprise that changed everything. As Voyager flew past, it measured Uranus's magnetic field and discovered it was wildly off-center. Unlike Earth's field, which aligns roughly with its rotational axis, Uranus's magnetic poles are tilted 60 degrees and displaced from the planet's core by a third of its radius. The result is a field that wobbles chaotically as the planet rotates, creating magnetic storms that twist and shift in unpredictable ways. Scientists had never seen anything like it. Voyager also discovered that Uranus is surrounded by delicate rings, dark, narrow, and nearly invisible. They're made of carbon-rich material, ancient and shadowy, perhaps remnants of shattered moons. Small shepherd satellites trace their edges, maintaining their sharp outlines through gravitational resonance, just as they do around Saturn. It was as if Uranus carried a secret, beauty hidden beneath restraint, motion concealed beneath stillness. And then there were the moons, 27 inches all, though Voyager 2 could only study a handful. Among them, Miranda stood out, a small patchwork world scarred with cliffs taller than Mount Everest and chasms that cut across hemispheres. Its fractured terrain seemed stitched together from multiple worlds, suggesting that Miranda may have once shattered and reassembled itself. Voyager's images showed a place that defied logic, chaotic, asymmetric, and hauntingly beautiful. As the spacecraft slipped past Uranus and continued toward Neptune, it looked back one last time. The planet's soft glow hung against the blackness like a lonely lantern in an infinite sea. There were no storms visible, no lightning flashes, only calm, an unbroken surface that seemed to hide more than it revealed. For decades, scientists puzzled over Uranus's strange lack of heat, its tilted axis, and its magnetic anomalies. Some suggest a massive impact long ago knocked it sideways, permanently altering its interior. Others think it formed differently altogether, a rogue world captured by the sun's gravity. Whatever the truth, Voyager's brief visit left more questions than answers. Uranus remains one of the most mysterious planets in our system. A quiet enigma, adrift at the edge of sunlight. To this day, no spacecraft has returned. It waits there still, slowly spinning on its side, keeping its secrets beneath that tranquil turquoise veil. And perhaps that's what makes it so haunting. Voyager showed us that even in silence, the universe has depth, that sometimes the calmest worlds carry the loudest mysteries. In 1989, Voyager 2 met the last of the giants. Neptune, a deep blue ghost spinning through the darkness, crowned with a great dark spot, a storm that seemed to gaze back. Beyond it lay nothing visible, just emptiness, the edge. Or so we thought. It was August 25th, 1989, when Voyager 2 reached Neptune, 12 years after it had first left Earth. By then, it was nearly 3 billion miles from home, operating on dwindling power, yet still faithfully awake. The cameras turned toward the final planet on its itinerary, and what appeared in those first images was mesmerizing. Neptune glowed with a deep sapphire hue, richer and darker than any world Voyager had ever seen. It wasn't the pale, calm blue of Uranus. It was a vibrant, living color, as though the planet itself were lit from within. Neptune's atmosphere is a world of constant motion. Voyager revealed winds that roar faster than sound, reaching nearly 1,200 miles per hour, the fastest recorded in the entire solar system. Imagine standing in an endless hurricane, where the air itself races faster than the speed of a jet. These winds carve immense patterns across the clouds, creating vortices and streaks that twist around the planet in silent fury. Then there was the Great Dark Spot, a vast storm system roughly the size of Earth, swirling in Neptune's southern hemisphere. Unlike Jupiter's ancient red spot, this one was fleeting. Voyager captured it in full detail, dark at the center, encircled by bright white methane clouds that rippled like foam on a churning sea. It was an eye of chaos that seemed to stare directly at the spacecraft, as if aware of being seen. Within just a few years after Voyager's departure, the storm would vanish completely, only to reappear elsewhere, as if Neptune itself were reshaping its own atmosphere in response to being watched. Voyager also discovered that Neptune radiates more than twice the energy it receives from the Sun. It glows with internal heat, the remnants of its ancient formation, warming an atmosphere that should, by all rights, be frozen solid. This internal fire drives its violent weather, fueling the winds and storms that give the planet its restless, beautiful face. But Neptune's mysteries didn't end with its atmosphere. As Voyager passed through its outer reaches, it found an intricate system of faint rings, thin, incomplete arcs of dust and rock. These arcs weren't supposed to exist. The physics of orbit predicted they should quickly spread out into full rings, but something, perhaps small, hidden moons, was shepherding them, maintaining their delicate, lopsided shapes. It was yet another puzzle whispered from the dark. And then there was Triton, Neptune's largest moon, and one of the strangest in the solar system. Voyager revealed an icy world of pink and white, with nitrogen geysers erupting miles into space, driven by sunlight faint as twilight. Triton orbits Neptune backward, against the planet's rotation, suggesting it wasn't born there at all, but captured long ago, a wandering object pulled into orbit by gravity's quiet hand. Beneath its frozen crust, some scientists believe, lies a hidden ocean, warmed by the faint tug of Neptune's tides. Even here, at the edge of the sun's reach, the ingredients for life might still exist. As Voyager 2 completed its flyby, it turned its camera back for one last look. Neptune hung suspended in the black, its azure glow fading into infinity. Beyond that point, there were no more planets to visit, no more worlds to map, only the great unknown stretching toward the stars. It was the end of the grand tour, the moment when exploration crossed the threshold into interstellar space. But endings in space are never truly endings, only transformations. Voyager 2's passage past Neptune marked the last time a human-made object would visit a new planet for decades. Yet, it also marked the beginning of something greater. Beyond Neptune lay the Kuiper Belt, the heliopause, and the infinite sea beyond the Sun's domain. Voyager had not only reached the edge of our solar system, it had opened the door to everything beyond it. And as Neptune's ghostly light faded behind, humanity's gaze turned forward. What waited in the dark ahead was not silence, but the next great mystery. The edge of the solar system, or perhaps the beginning of forever. After Neptune, Voyager 2's cameras went silent. The mission was over. But engineers left the power on, a small glowing heartbeat in the dark. No one expected what came next. Whispers in the data. Patterns that didn't belong to any known cosmic source. By the autumn of 1989, the Grand Tour had officially ended. Voyager 2 had completed its final planetary encounter, its final photographs transmitted back to Earth, and its camera system was shut down to preserve energy. In NASA's quiet control rooms, there was a sense of melancholy, a farewell not only to a mission, but to an era. For 12 years, the Voyagers had been our eyes, showing us the outer worlds for the first time. Now, they were to become something different, listeners in the dark. Without the need to take more images, the spacecraft's remaining instruments focused on the invisible. They began measuring the delicate hum of cosmic rays, the faint murmur of plasma, the pull of interstellar magnetic fields. Voyager 1 was heading north above the plane of the solar system, Voyager 2 south. Together, they were like twin sentinels drifting into the night, tracing the outermost breadth of the sun's influence, the heliosphere. Inside NASA's Deep Space Network, engineers monitored the slow, rhythmic pulses that signaled the Voyagers were still alive. Each signal took over 16 hours to travel one way, a thin thread of light stretched across billions of kilometers. Sometimes the transmission was so faint that it was buried in static, and teams would spend days pulling fragments of data from the noise. Each bit of information felt sacred, a whisper from the edge of home. But then, strange things began to happen. In early 1990, a series of fluctuations appeared in Voyager 2's plasma wave data. They weren't random, they repeated, faintly, like the echo of something structured. The frequencies didn't match solar wind patterns, cosmic rays, or any known instrument error. The team dismissed it at first as a software glitch, until the same anomalies appeared again, this time in Voyager 1's instruments, separated by billions of miles. It was as if something out there, something beyond the reach of sunlight, was stirring. The data came in soft pulses, almost rhythmic, too slow for radio interference, too patterned for coincidence. To some engineers, it resembled a kind of heartbeat, a steady rise and fall, like breathing in the void. They labelled it simply as non-terrestrial interference and archived the findings. Meanwhile, the Voyagers pressed onward. Their power sources, tiny nuclear hearts, continued to hum steadily, keeping a few instruments alive. Each year, NASA engineers would switch off another system to conserve energy. Heaters, gyroscopes, backup transmitters, until only the essentials remained. Yet, the spacecrafts endured the cold, surviving temperatures near absolute zero, their circuits coated in frost, their signals growing ever fainter. In 1990, just before Voyager 1's camera was powered down for good, it turned back one last time. From 6 billion kilometers away, it captured a photograph of Earth. A single point of light suspended in a beam of sunlight. Carl Sagan would later call it the pale blue dot. It became an image not of data, but of meaning, a portrait of everything we are, seen from the edge of the known. After that, both Voyagers entered their long drift. The silence between transmissions grew, the delays lengthened. Yet, through that silence, the anomalies persisted. Small variations in the plasma data, whispers that didn't belong. Engineers ran simulations, checked equipment, cross-referenced deep space weather. Nothing explained them. Perhaps it was nothing more than the subtle dance of interstellar particles, or perhaps it was something new entirely, a phenomenon never before encountered. The deeper Voyager travelled, the more the data began to hint at structure in the supposed emptiness, fluctuations in the density of space itself. And so the mission continued, long after its original purpose was fulfilled. The cameras slept, the scientists grew older, and the signals took longer and longer to return. But those whispers in the dark remained. Gentle, repeating, persistent, as if the universe itself were acknowledging the Voyager's presence, softly murmuring back. It was no longer a mission of exploration, but of endurance. A quiet goodbye that refused to end. And somewhere, in that infinite black, 2 human-made hearts kept beating. Tiny embers of curiosity, still listening for an answer that might never come. There's a boundary around our solar system called the heliopause, the place where the sun's influence ends and interstellar space begins. Voyager 1 crossed it in 2012. For the first time, a human-made object entered the true unknown. And something noticed. For decades, scientists had known the heliopause existed, but no one had ever seen it. It's not a wall, nor a physical line, but a vast, shifting frontier, a cosmic shoreline where the solar wind, that continuous stream of charged particles from the sun, collides with the interstellar medium that drifts between the stars. It's the edge of the sun's breath, the outermost ripple of our star's dominion. Inside the heliosphere, everything is touched by the sun's energy, its wind, its magnetism, its light. Beyond it, the space between stars follows its own laws. When Voyager 1 approached this invisible border, it had already travelled more than 18 billion kilometres. The sun had become just another star in the distance. Solar signals arrived so weakly that the spacecraft's instruments could barely detect them. The data stream slowed, stretched thin by time and distance, and then, one day, the readings changed. The charged particles from the sun began to drop. Cosmic rays from deep space surged. Magnetic field readings shifted in direction but not in strength, confusing scientists who expected a clean, measurable transition. Instead, the boundary was complex, layered, uneven, alive. Voyager had reached the frontier between 2 worlds, the end of one wind and the beginning of another. On August 25, 2012, humanity officially became an interstellar species. The moment was quiet. There was no signal or flare, no visual marker, just data, faint and slow, taking 17 hours to reach Earth. But buried in that data was history. Voyager had entered the dark between the stars. The space outside the sun's reach wasn't empty. It was denser, richer, full of cosmic particles that had been drifting for billions of years, matter from distant supernovae, dust from dead stars, the ashes of galaxies. Voyager had touched the skin of eternity. And yet, as the spacecraft drifted farther into that silence, strange oscillations began to appear in the plasma wave readings, faint vibrations like the trembling of air before a storm. The signal wasn't random. It pulsed, faded, returned, then shifted again. The frequency matched no known interstellar phenomenon. Scientists described it as a plasma wave event, but the pattern was too precise, too rhythmic, as if something on the other side of the heliopause had responded to the probe's crossing. It was as though the universe had a boundary not just of energy, but of awareness, a place where human-made sound met the stillness of the infinite. Every vibration Voyager detected was translated into tone. When played through speakers, it sounded like a low, haunting hum, a song of the void itself, steady, distant, and impossibly beautiful. As data continued to stream in, the idea of the heliopause shifted. It wasn't simply the end of the sun's reach, but a kind of cosmic membrane, dynamic, rippling, sensitive. Like the surface of an ocean, it moved in waves, responding to solar storms, cosmic bursts, and perhaps to the faint whisper of a machine passing through. Voyager 1, a relic of 1,970 seconds engineering, had accomplished something profound. It had carried a piece of humanity, our curiosity, our music, our heartbeat, across the last frontier of the solar system. And in doing so, it found that the universe does not end, it only changes its texture. The solar wind doesn't vanish, it fades into the breath of the stars. Even now, Voyager continues its slow drift, billions of miles beyond the sun's reach. The faint hums still come through, unpredictable and patient. Some call them cosmic plasma waves. Others, more poetically, call them the heartbeat of interstellar space. Whatever they are, they remind us of one truth, that even at the edge of everything we know, something out there still listens. The cosmic shoreline isn't a boundary, it's an invitation. A place where one kind of light ends and another begins. Voyager's instruments detected something unexpected, plasma waves vibrating in the emptiness. It was as if space itself was singing. Scientists called it interstellar plasma oscillation, but the rhythm was too precise, too structured, almost intentional. When Voyager 1 crossed the heliopause, it entered a realm no spacecraft had ever touched before. The interstellar medium, the vast ocean of charged particles drifting between the stars. In this deep silence, there is no air, no sound in the way we know it. Yet, as Voyager's plasma wave sensor began to record faint signals, the data revealed vibrations rippling through space. These were not the kind of sounds that travel through air. They were oscillations in plasma, the ionized gas that fills the spaces between suns. In April 2013, the data arrived at NASA's Deep Space Network. It looked ordinary at first, just another line of faint telemetry, distorted by billions of miles of distance. But when engineers converted the plasma frequency into audio, a strange melodic tone emerged. A low, rising hum that seemed to swell and fade in patterns. It wasn't random, it had rhythm. Space, for the first time, had a voice. Scientists named it interstellar plasma oscillation, the vibration of electrons as they interact with magnetic fields and cosmic radiation. But behind the technical language, there was wonder. The tones were hauntingly regular, their spacing almost musical. Some bursts lasted seconds, others minutes, as though something vast and unseen was breathing around the spacecraft. To the human ear, it sounded like the singing of the void itself, not empty, but alive with energy. The pitch would climb gently, like the swell of a choir, before falling back into silence. Sometimes the hum would vanish for months, only to return slightly altered, as if the void were changing its tune. scientists noticed that the vibrations coincided with fluctuations in cosmic radiation and solar storms, suggesting that even out here, in the space between stars, the sun's distant heartbeat could still be heard. But there was something else too. The patterns didn't always align with known cosmic events. Some appeared unprovoked, resonating at intervals that defied the randomness of natural plasma motion. The data analysts joked that Voyager was hearing echoes, but no one could say of what. When plotted visually, the oscillations formed delicate curves, symmetrical and recurring, like signatures. The same waveforms reappeared months apart, slightly shifted, but undeniably connected, as if Voyager were hearing the same chorus from different directions in space. Some speculated that the probe was passing through structured plasma regions, invisible filaments left behind by long-dead stars. Others wondered if these oscillations were part of a deeper, galactic resonance, a kind of background rhythm embedded in the fabric of interstellar space itself. The public soon heard these sounds too. NASA released the recordings, and listeners described them as eerie, beautiful, even emotional. It was a song with no composer, a melody written by the universe. People compared it to the sound of a choir, a whale's call, the voice of the cosmos itself. It stirred something ancient in the human imagination, the feeling that the void was not truly empty, but awake. As Voyager continued to drift farther from the sun, the plasma tones deepened, slowing into longer, softer pulses. The spacecraft seemed to be moving through zones of differing density, cosmic tides of charged particles, each with its own resonance. It was as though the probe were floating through invisible waves, and the sensors were its ears. To the scientists, it was data. To everyone else, it was poetry. For the first time, we could listen to the silence between the stars and discover that it wasn't silence at all. The void was singing. The universe had always been humming. We just hadn't gone far enough to hear it. And perhaps, deep down, that's what made it so haunting. The song of space wasn't just random physics. It felt like a response, like the cosmos itself acknowledging that something from within had finally come to listen. When the data was filtered, a repeating pattern emerged. A rise and fall every 67 hours. No natural source fit. The signal seemed to fade and reappear, as if moving through something unseen, or reacting to the probe itself. It began quietly, buried in the static of Voyager's faint transmissions. Engineers at NASA's Deep Space Network noticed a subtle fluctuation in the plasma readings, so regular that it stood out even against the chaotic hum of interstellar noise. Every 67 hours, the same gentle oscillation pulsed through the data. It wasn't loud, it wasn't random. It was deliberate, or at least, it seemed to be. At first, it was dismissed as interference. Signals from deep space often pick up distortions, cosmic rays striking circuits, solar wind ripples echoing through the antenna feed. But this wasn't noise. When they isolated the source, it followed Voyager itself, traveling with the probe, fading and returning at precise intervals. As the spacecraft moved farther from the sun, the pattern didn't weaken. It grew clearer. Scientists checked everything: onboard systems, power fluctuations, the aging nuclear generators that hummed within the craft. But nothing matched the 67-hour rhythm. It wasn't internal. It was coming from outside, somewhere in the black between the stars. The plasma wave instrument translated these fluctuations into tones, and what emerged was haunting. A rise, a pause, a fall, a sound like breathing. Not in a literal sense, of course, but in rhythm. A cycle of tension and release, pulse and rest. Over time, this pattern began to shift ever so slightly, as if responding to changes in Voyager's movement or orientation. It was almost interactive. In 2013, the data team ran long-term analysis to chart the signal's consistency. Over months, they found that it aligned loosely with the spacecraft's roll maneuvers, tiny, automatic adjustments that kept its antenna pointed toward Earth. Yet, the timing didn't quite fit. The pulses sometimes arrived before the roll commands were executed, as if anticipating them. For a machine billions of miles away, this was impossible. Unless, of course, it wasn't the spacecraft being affected, but the space around it. One hypothesis suggested that Voyager had entered a region of structured plasma, a filament of denser interstellar medium that bent and flexed like a magnetic current. As the probe drifted through it, the waves could have reflected, creating a cyclical pattern in the data. Another theory was more unsettling, that something in the interstellar field was reacting to the probe's own radio emissions, a kind of feedback loop between Voyager and the medium itself, like an echo that learns the voice it repeats. To visualize this, imagine tossing a pebble into a still pond. The ripples spread, hit the edge, and bounce back, overlapping, creating interference patterns that look almost organized. Voyager might have been the pebble, the heliopause, the pond, the echo, something else entirely. Then, something even stranger happened. During one transmission cycle, the pattern broke, not into noise, but into harmony. The plasma frequency doubled, split into two parallel waves, and then recombined. For a brief few seconds, the tone formed a near-perfect interval, the same mathematical ratio found in music's simplest chords. When played through speakers, it sounded eerily melodic. The data log noted the anomaly, but offered no explanation. Statistically, it was a coincidence, plasma densities aligning at just the right time. But for those who heard it, it felt like something more. The universe, for a moment, seemed to be tuning itself. Even now, the 67-hour signal remains one of the more curious mysteries in Voyager's later data. No confirmed source, no predictable origin, no solar influence, just a rhythm that drifts between order and silence, repeating faintly, as if marking time in a place where time itself has no meaning. Perhaps it was nothing, a natural resonance in the plasma, a quirk of space. Or maybe it was the first sign that the emptiness beyond the sun isn't truly empty at all, that when we send our voices into the dark long enough, something eventually hums back. In 2014, Voyager 1's cameras, long thought useless, picked up a faint glimmer ahead, a subtle reflection, too steady to be a star, too distant to be debris. Engineers called it an anomaly. Others quietly wondered if Voyager had seen the first light beyond our sun's reach. By that time, Voyager 1 had been travelling through interstellar space for nearly 2 years. Its cameras were technically offline, their systems dormant to conserve power. But during a routine diagnostic test, a tiny voltage fluctuation triggered one of the imaging circuits. What returned wasn't an image in the usual sense, but a faint pixelated trace, a soft point of light lingering at the edge of detection. At first, the team assumed it was a cosmic ray strike, a random particle hitting the sensor. But when they cross-checked the next few data packets, the point was still there. Steady, unmoving, and over the course of several transmissions, it didn't fade, it simply waited. It wasn't a star. Stars twinkle, shift, and vary with distance. It wasn't the sun, whose light was far too dim to reflect at that range. Nor was it any known object, no planet, no asteroid, no fragment of space debris. Whatever it was, it existed in a region thought to be completely dark. The engineers logged it as Luminal Anomaly 1. In official records, it was listed as a probable sensor artifact, a false reading caused by residual charge or stray radiation. But quietly, among a few of the scientists who had worked with Voyager since the beginning, questions began to form. What if the light wasn't a glitch? What if it was real? Something faint, something small, but tangible. Over the next few months, analysts pored through old telemetry data, tracing every possible source. The reflection's spectral signature didn't match that of solar light. Instead, it resembled something diffuse, scattered across multiple wavelengths, like light passing through mist. When the data was translated into brightness curves, it showed an oscillation, a pulse, the same slow rhythm that had been detected in the plasma waves months earlier. The connection was hard to ignore. When scientists ran a simulation of Voyager's trajectory, they discovered that the light appeared to follow the probe's heading, not behind it, not alongside, but directly ahead, as if leading it. Every adjustment Voyager made to its orientation, the glimmer remained fixed in the same position relative to its path. NASA released no public statement beyond the technical report, but the community noticed. Independent researchers speculated that Voyager might have passed through a region of denser dust, particles fine enough to reflect stray starlight. Others proposed something stranger, that the reflection was caused by Voyager's own radio waves scattering off a faint plasma boundary ahead of it, creating the illusion of light, a kind of electromagnetic mirage. Still, some of the data defied easy explanation. The reflection's consistency was too perfect. No known dust field would remain that uniform for months. It shimmered faintly, like the reflection of a lantern over still water, wavering, but never gone. In one of the archived mission logs, a notation appears beside the data stream. Possible photonic echo. Investigate further. The phrase was never used again in Voyager's official documentation, but to those who have studied the mission's later years, it remains a fascinating mystery. A ghostly hint that somewhere beyond the heliopause, light behaves differently. Perhaps it was nothing more than an artifact, a random flicker, amplified by hope. Or perhaps it was the first glimpse of a structure we don't yet understand, a surface, a boundary, or even a veil of energy stretching across the edge of our sun's domain. Whatever the case, the faint light was the first visual signal from beyond the solar bubble, a quiet reminder that the void might not be as dark as we once believed. Voyager, sailing deeper into eternity, had seen something shimmer in the infinite. And though no one could say for certain what it was, one truth remained. The farther we travel into the darkness, the more it begins to look back. The radio transmissions began changing, small fluctuations in timing, as if the signal was being delayed and then corrected. It was as though something out there was echoing Voyager's call, sending it back slightly altered, as if answering. It started subtly, small inconsistencies in the telemetry streams returning from Voyager 1. The engineers first noticed the delays in 2015. The probe's regular transmissions, which had arrived with near-clockwork precision for decades, began to drift by milliseconds. At first, the deviations were dismissed as artifacts of distance. After all, the spacecraft was nearly 20 billion kilometers away. But the pattern grew stranger. Sometimes the delay extended, then, a few transmissions later, it shortened again, as if the signal had been caught, adjusted and released. Radio engineers double-checked every system in the chain, the deep space network antennas, the amplifiers, even Earth's ionospheric interference. Nothing explained the rhythmic timing corrections. It was as though the signal were bouncing off something between Voyager and Earth, a structure invisible to telescopes, transparent to light, but capable of reflecting radio waves ever so slightly. When the data was examined more closely, they discovered another anomaly. The frequency of the signal, the faint carrier wave that Voyager used to speak with Earth, was being subtly modulated, as if something was adding a whisper of its own. Not a random interference pattern, but a delicate oscillation, like the ripple of a fingerprint pressed into sound. It was faint. Too faint to be heard in real time, but when the raw data was converted into audio frequencies and amplified, the team heard something extraordinary. A series of tones buried beneath the carrier wave, uneven but rhythmic, rising and falling in complex intervals. They sounded eerily similar to the plasma oscillations Voyager had recorded after crossing the heliopause, the same haunting hum of interstellar space. This led to a new hypothesis. Perhaps the signals weren't being reflected or interfered with, but transformed. As the radio waves passed through the turbulent plasma at the edge of interstellar space, they might have been subtly refracted, split and rejoined, like light through water. The result would be a kind of cosmic echo, shaped by the very medium it passed through, a natural, if otherworldly, phenomenon. But there was a problem. The changes weren't random. They mirrored Voyager's own transmissions, repeating fragments of its data at reduced volume, as though something was returning the signal intentionally. Astonishingly, some of these echoes matched data packets Voyager had sent days earlier. The patterns were incomplete, distorted, yet unmistakably familiar. Bits of information that had already been received on Earth, now arriving again, altered and delayed, as if rewritten by a foreign hand. Scientists tested the idea that the probe's signal could have reflected off plasma structures, creating multi-day echoes. The distances, however, didn't line up. For a delay of that length, the reflecting object would need to be tens of billions of kilometers away, far beyond Voyager's known position. In one internal memo, a communications specialist described the phenomenon poetically. The oddities continued for months. Each time NASA sent commands to Voyager, the returning data would come back with these faint imprints, bits repeated, slightly inverted, or phase-shifted. Then, as suddenly as they began, the anomalies faded. The transmissions returned to normal, leaving only questions in their wake. Officially, the explanation remains technical. Reflections, plasma interference, or unaccounted Doppler shifts. But within the mission's archives, the phenomenon is listed under a curious internal tag: Echo Event, Class B. To those who worked on the project, it was unforgettable. Because for the first time, the emptiness had spoken back, not in words but in rhythm, a response not of meaning but of mimicry. Perhaps it was coincidence. Or perhaps, when Voyager's voice reached far enough into the dark, something, or the very structure of space itself, chose to sing in harmony. Then, for 22 hours, Voyager 1 went completely silent. Every system appeared normal, every transmitter operational, yet nothing came through. When contact returned, the data stream contained one unexplained entry, a burst of binary code that, when translated, read simply 1. It happened on a quiet spring morning in 2016. Routine communication passes between Earth and Voyager. One had become almost meditative by then. Long, slow exchanges across the dark, separated by billions of miles and nearly 17 hours of delay. The spacecraft had been stable for years, its instruments responding faithfully. At 0412 UTC, the Deep Space Network recorded the last normal packet of data from the probe. Telemetry showed no fault, no warning, no degradation. Then, nothing. The signal vanished mid-transmission, not fading or weakening but stopping altogether. The line went flat. Engineers ran diagnostics on the antennas. No atmospheric disruptions, no solar interference, no instrument failure. Voyager was simply gone from the airwaves. For the next 22 hours, NASA's largest dishes in Canberra, Madrid, and Goldstone listened in unison, searching for a trace. The silence was total. Inside Mission Control, there was unease, not panic, but the hollow weight of uncertainty. For a probe that had travelled flawlessly for nearly 40 years, silence was unnatural. The team combed through data logs, checking for cosmic ray hits or errors in the timing sequences. Nothing explained the disappearance. The spacecraft's predicted position was precise to within kilometers. It should have been there. And then, just as abruptly as it had gone quiet, Voyager's signal returned. Strong, steady, intact. Every system check came back normal. Power, temperature, voltage, all nominal. It was as if the spacecraft had never left. But when they reviewed the recovered data stream, there was something strange embedded between two normal telemetry packets. A cluster of bits that didn't correspond to any known command or sensor output. The pattern was simple, repeating binary code, perfectly structured, forming the ASCII representation of one word, 1. It wasn't a checksum, a transmission error, or background noise. It was intentional, ordered, complete. The string lasted for only half a second before the probe resumed normal operation, transmitting plasma and magnetic readings as if nothing had happened. Some engineers believed it was a glitch, a corrupted memory sector spitting out random bits that coincidentally formed a word. Others were less sure. The odds of such precise ordering were astronomically low. One scientist remarked in the post-event log, "It's like Voyager said something, and then went quiet to see if we heard." In the weeks that followed, NASA performed full system sweeps. Voyager's onboard computer showed no memory faults. The binary wasn't generated by any known process. There was no record of the command being sent, and no automated routine that could produce human-readable text. What made the event more mysterious was the timing. Just before the signal loss, Voyager's magnetometer had recorded a sharp, localized fluctuation, a sudden drop in the interstellar magnetic field, followed by a return to normal. It was as if the probe had passed through a pocket of distortion, a void within the void. Speculation rippled quietly through the scientific community. Had the signal been momentarily bent, delayed, or redirected by a plasma wave? Could the message have been a compression artifact, a mathematical quirk of data repair that just happened to spell a word? No definitive answer came. The data was archived, classified under non-repeatable anomaly. Voyager's transmissions continued unchanged, but to those who had listened to that long silence, to the engineers who waited through the empty hours, the moment carried an eerie significance. For 22 hours, a machine older than most of its operators had disappeared into the dark. And when it came back, it spoke a single word, simple, primal, and absolute. 1. Was it a coincidence, a glitch, or was it, in some quiet, unfathomable way, a statement, perhaps a reminder, that out there, in the deep between stars, even silence has meaning? The space outside our sun's bubble isn't empty. It's filled with cosmic dust, high-energy particles, and magnetic currents that twist through eternity. Voyager was the first to touch it, and what it felt there didn't match the models. It felt structured, layered, like a skin. The heliopause, once just a theoretical boundary, was expected to be a clean transition, a simple border where the solar wind gives way to the interstellar medium. But when Voyager 1 crossed it in 2012, the data told a stranger story. The probe didn't pass through a single, sharp edge. Instead, it moved through multiple layers, alternating bands of solar and interstellar plasma, stacked like the folds of an unseen fabric. Each layer hummed with its own frequency, its own rhythm, as though the sun's influence didn't end, but bled outward into infinity. It was the first time humanity touched the true environment between stars, and it wasn't what anyone expected. The magnetic field readings didn't align with predictions. Instead of dropping sharply, they twisted, fluctuated, and then realigned, as if the boundary itself was shifting around the probe. Voyager's magnetometer detected waves rolling through space, slow, undulating currents of energy, rising and falling every few hours, like the breathing of something vast. To visualize it, scientists described the heliopause not as a wall, but as a membrane, elastic, flexible, alive. Solar particles pressed outward from within, while the interstellar medium pushed back from without. The result was a cosmic skin, shimmering with invisible pressure, rippling as the forces of two realms met. Voyager was the first and only object to touch it, and it responded. When the plasma wave detector activated, it picked up bursts of vibration that shouldn't have existed in such low-density space. The tones were faint but organized, a subtle variation in electron density that repeated in waves, like ripples across a pond. The farther Voyager drifted, the more frequent they became. It was as if the spacecraft had entered a zone of structured interference, where invisible forces wove together into something tangible. Then came the shock. The data revealed that the heliopause wasn't stationary. It moved. Each time a solar flare erupted, the boundary pulsed outward. Months later, As the solar wind weakened, it contracted again. Voyager, caught within these movements, registered them like tides, pressure building, then easing, as though space itself had a heartbeat. Even more mysterious was the magnetic alignment. Scientists expected the interstellar field to tilt sharply away from the Sun's own. Instead, it remained parallel, perfectly aligned, as though the two magnetic realms were synchronized. This defied decades of theoretical modeling. It suggested a continuity that no one had imagined. That the Sun's invisible touch extends farther than its light, threading into the galaxy itself. Some researchers began to describe it as a magnetic cocoon, a vast sheath of interstellar current wrapping the solar system. Voyager, drifting along its edge, was like an insect walking across the surface of a soap bubble, feeling the subtle vibrations of something far larger than itself. The space beyond was denser than expected too, not the vast vacuum once imagined, but filled with cosmic dust, atomic hydrogen, and fragments of charged matter. Voyager's detectors caught traces of heavy ions, remnants of supernovae that had exploded millions of years ago. In other words, the spacecraft wasn't just crossing a boundary, it was entering the ashes of dead stars. For the scientists watching from Earth, it was humbling. For the first time, we were directly touching the material between solar systems, the dust from which worlds are born and to which they return. Voyager wasn't just mapping distance, it was mapping memory. And yet, within that structured silence, one question lingered. The data didn't just show patterns, it showed persistence, organized layers repeating in ways that suggested purpose. Not intelligence in the human sense, but order on a cosmic scale. Maybe the heliopause isn't a border at all. Maybe it's a threshold, the skin of a living system, separating the warmth of the sun from the cold beyond. And Voyager, by pressing its fragile body against that edge, didn't just find the end of the solar wind. It may have found the place where the universe begins to dream of new suns. Voyager's magnetometer registered a field stronger than expected, not fading with distance but fluctuating like a heartbeat. Some believe it was measuring the interstellar medium itself. Others think it found something moving through it. After crossing the heliopause, Voyager's sensors were expected to encounter a weakening magnetic field, a gradual drop in strength as the influence of the Sun gave way to the vast interstellar domain. Instead, the readings told a different story. The magnetic field didn't weaken, it pulsed. At first, the fluctuations were subtle. Small rises and dips occurring in rhythmic cycles. The magnetometer needle twitched in ways that suggested an underlying order, almost biological in its regularity. Every few days, the field would surge, then fall, then rise again, like a slow cosmic respiration. This wasn't supposed to happen. Beyond the heliopause, magnetic fields should be diffuse, random, chaotic, the tangled remains of stellar explosions billions of years old. Yet here, they seemed organized. Scientists ran simulations to model the anomaly. Some theorized that Voyager had entered a magnetic filament, a concentrated tendril of interstellar current threading through the galaxy. These filaments are rare and poorly understood, long strands of charged particles that stretch across light years, carrying electricity through space. They are thought to connect regions of plasma, like cosmic veins running between stars. If Voyager had intersected one, it would explain the field's strength, but not its pulse. Others suggested a more dynamic explanation, that the fluctuations were caused by moving structures within the plasma itself, waves or vortices traveling through the medium, brushing against Voyager as they passed. In essence, the spacecraft might have been feeling the turbulence of interstellar weather, invisible storms that drift between stars for centuries. But there was something odd about the timing. The magnetic pulses seemed to coincide loosely with other anomalies in Voyager's data. Tiny shifts in radio transmission timing, irregularities in plasma density, and faint tonal oscillations that matched the hum detected months earlier. It was as if everything, the light, the plasma, and the magnetism, were moving together, synchronized by some deeper pattern. When researchers plotted the field data across time, the waveform formed a repeating pattern that eerily resembled an electrocardiogram, peaks and valleys aligned with mathematical precision. It was metaphorical, of course, but the image was haunting, the heart of interstellar space, beating in quiet rhythm. To many, the phenomenon symbolized something profound, that even in the vacuum beyond the sun, there is structure, motion, perhaps even purpose. The universe isn't still, it's alive with invisible currents, constantly in motion, constantly speaking in the language of magnetism. Voyager's magnetometer, a simple spinning arm with 3 sensors, was never designed to capture something so complex. And yet, its data showed a whisper of a deeper truth, that space is not an empty sea, but an ocean of energy, threaded by fields that stretch beyond comprehension. Each pulse Voyager recorded was like a note in a symphony, too vast for us to hear in full. A few independent analysts speculated further, perhaps recklessly. They proposed that the magnetic fluctuations might not just be natural waves, but distortions, the wake of something moving through the medium. A body, maybe massive, maybe not, carving paths through the interstellar plasma like a ship through mist. The idea wasn't new. Astronomers have long theorized that invisible objects, rogue planets, or even small black holes could drift through interstellar space, unseen but not unfelt. If one had passed near Voyager's trajectory, it might have left behind a trace, a shiver in the field. Officially, NASA remained cautious. The fluctuations, they said, were consistent with local interstellar turbulence. But in private memos, a few engineers admitted something quietly unsettling. The magnetic pulse pattern wasn't entirely random. Its rhythm matched the intervals of Voyager's own transmission cycles. A near coincidence, perhaps, but one that made some wonder if the craft and the current were, in some unknown way, resonating together. Like a voice meeting its echo. Even now, the data continues to show faint, regular oscillations in the field around Voyager. The probe moves farther into the void, yet the current persists, steady, persistent, watching. The universe, it seems, has its own pulse, and for the first time in history, something human was close enough to feel it. Temperatures dropped lower than predicted. Radiation levels changed. And then, a dip. A sudden absence, as though the probe had passed through a shadow in the vacuum, a place where the laws of physics felt thinner, stretched by something vast and unseen. By 2017, Voyager 1 had drifted more than 20 billion kilometers from the Sun. Its plutonium core still pulsed with a faint warmth, just enough to keep a handful of instruments alive. The spacecraft was alone now, no light, no planets, no gravitational landmarks to guide it, only darkness and data. But then, something subtle changed. Over several weeks, the onboard sensors began recording a gradual decline in temperature, far below what thermal models predicted. This wasn't supposed to happen. The decay of its nuclear generator, though slow, was constant and predictable. And yet, the readings suggested Voyager was cooling faster than physics allowed, as though heat itself was bleeding away into something unseen. At first, engineers blamed calibration drift. The instruments were decades old. Perhaps their sensors were degrading. But the radiation readings changed too. The background cosmic rays, the constant drizzle of high-energy particles that fills interstellar space, suddenly thinned. Not vanished, but dipped, sharply and uniformly, as though Voyager had entered a zone of shelter in an endless storm. The region lasted 12 hours. Then, as abruptly as it began, everything returned to normal. Temperatures rose. Radiation resumed its steady hum. The vacuum, it seemed, had a shadow. Scientists were cautious with their interpretations. Space, after all, is not uniform. It ripples with magnetic waves and density variations. cosmic weather sculpted by ancient supernovae and interstellar winds. Perhaps Voyager had passed through one of these invisible eddies, a pocket of altered space where charged particles were briefly deflected. But the data didn't quite fit. The drop in temperature coincided with a faint change in the probe's trajectory, a minute deviation, just within the limits of detection. The difference was microscopic, but measurable. Something, somewhere, had pulled on Voyager. Not enough to alter its path significantly, just enough to make it noticeable. The official analysis called it a localized plasma density fluctuation. Unofficially, some of the engineers gave it another name, the cold zone. For them, the numbers hinted at something more than turbulence, something structured. If the interstellar medium behaved like an ocean, then this wasn't a random current. It was more like an undersea trench, a pocket where energy itself seemed to drain. The probe's instruments, tuned to measure electrons and ions, registered near silence during that passage. Space wasn't just quiet, it was absent. And yet, in that absence, Voyager recorded a faint anomaly. A low-frequency hum, barely above the noise threshold, oscillating in an uneven rhythm. When the data was converted to sound, it produced a slow, wavering tone, deep, hollow, and hauntingly organic. The waveform repeated every 2.4 seconds, too slow for plasma vibrations, too fast for magnetic drift. It seemed to come from nowhere, and end in nothing. After the event, when scientists replayed the data, one of them described the sound as like listening to a room exhale. No one could explain why the region was colder or why radiation fell so dramatically. The interstellar medium should be nearly uniform at those scales. Yet Voyager had found a pocket where energy bent away, where even the most fundamental constants, temperature, radiation density, magnetism, felt thinner. Some proposed it might be a void left by a long-dead star, a remnant bubble in the galactic plasma. Others speculated it could be the wake of something massive passing through eons ago, the imprint of motion carved into space-time itself. Whatever it was, Voyager passed through it and survived, emerging unchanged but not untouched. The data still showed that strange thermal dip, a brief, impossible cold that defied every model. It was a reminder that even in the places where light cannot reach, there are gradients, places where the universe folds upon itself, where the rules soften just enough for mystery to slip through. And in that quiet, fleeting shadow, a machine built by human hands became the first thing ever to touch the thin edge of physics, and to feel the chill of something larger than understanding. Radio astronomers later noticed a faint hum in the background noise of deep space, one that matched Voyager's own transmissions, but delayed by years. If true, it would mean the probe's signals were bouncing off something unimaginable beyond the heliopause. The discovery wasn't made by NASA, but by a small team of independent astronomers in Australia, monitoring the Deep Space Network frequencies as part of a long-term data project. For years, they had been cataloguing faint background noise, the cosmic static that fills the radio sky. But in early 2018, they noticed something peculiar. Hidden beneath the hiss of interstellar interference was a signal that shouldn't exist. A whisper that mirrored Voyager's carrier frequency almost exactly, but shifted, delayed by a precise, consistent interval of 2.6 years. At first, it seemed impossible. Radio signals from Voyager travel in one direction, outward. Once they leave the solar system, they continue forever into the black. There's nothing out there to bounce them back. No clouds dense enough to reflect radio waves, no surfaces to mirror the transmission. Yet here it was, Voyager's own voice, faint but recognizable, calling back from the dark. The team cross-checked the data with historical logs. The waveform was identical to a transmission Voyager 1 had sent in late 2015. A calibration burst used to test its transmitter power. Nothing special, just a repeating tone. But now, that same tone appeared again in their receivers, weaker, distorted, but still mathematically intact. They ran the numbers again. The delay was too long to be an Earth-based reflection, and too clean to be random noise. Whatever had mirrored the signal was light years away, far beyond the heliopause, perhaps even outside the region where the sun's magnetic field still has influence. When the astronomers shared their findings with NASA, the agency reran their own deep space scans. They too detected faint harmonics at similar frequencies, though the source was difficult to isolate. Officially, the explanation was cautious. Possible long-delayed echoes, LDEs, a known but poorly understood radio phenomenon where signals can return after years, bent and slowed by plasma irregularities in space. But even the most generous models couldn't account for the clarity or timing of the Voyager echo. Long-delayed echoes have haunted astronomers since the dawn of radio. As early as the 1,920 seconds, operators reported receiving their own signals seconds or minutes after transmission, faint, delayed duplicates, as if the Earth's ionosphere had become a cosmic mirror. But those were seconds. This was years. And the signal came from a region no known structure could explain. When NASA converted the return tone into audio, what emerged was eerie. Voyager's steady mechanical pulse was still there, but layered over it was a second hum, faint and wavering, rising and falling in slow cycles. A beat, not interference but modulation. The signal had changed on its way back. It had depth. In spectral analysis, the waveform showed harmonic overtones that didn't exist in the original. It was as if the signal had passed through something, or someone, and carried the imprint of that interaction home. Like a beam of light refracted by glass, it had been split, altered, and recombined. The implications were staggering. If the echo were real, it meant that something out there was dense enough, organized enough to reflect radio energy, yet diffuse enough to remain invisible. Some theorized it could be a shell of plasma at the edge of the heliopause, forming a kind of mirror. Others speculated that Voyager had grazed an interstellar object, a magnetic anomaly, or even a remnant structure from the early galaxy. But there was one final detail that haunted everyone who studied it. When the time delay was analyzed, it matched not just the distance light would travel to Voyager and back, but slightly more, as if the signal had taken a longer path, or had been sent from farther away than Voyager itself. To this day, the Voyager echo remains one of the most mysterious pieces of data ever recorded. It's never been replicated, and no second echo has appeared, but the idea lingers that something beyond the sun's reach heard our signal, held it for a while, and then sent it back, altered. Maybe it wasn't a reflection at all, maybe it was a reply. Buried in archived Voyager files, researchers discovered readings labelled non-physical event, frequencies that corresponded to no known phenomenon. Yet every time the signal reappeared, the same subtle pattern showed up, like a cosmic fingerprint. It began with a graduate student in 2019, combing through decades of unreviewed Voyager telemetry. Much of the data from the late 1980s and early 1990s had been archived on magnetic tapes. Raw, unfiltered streams of binary code stored for safekeeping and largely forgotten. The student, working on a machine learning algorithm designed to identify transmission anomalies, stumbled upon something strange. Recurring data spikes that didn't fit any known category. Each spike appeared as a narrowband frequency, lasting less than a second, faint, consistent, and perfectly structured. At first glance, they looked like compression artifacts or transmission errors, but when the team reconstructed them, the waveforms revealed intricate, symmetrical oscillations. They weren't random. They followed a mathematical rhythm, repeating patterns of ratios that mirrored the Fibonacci sequence. The data tags read, non-physical event. That label was rare, a legacy classification from early Voyager protocols. It was used for readings that didn't correspond to any instrument input, as if the spacecraft had recorded a signal from nowhere. There were only a handful of such entries in Voyager's entire history. Yet, here they were, dozens of them, scattered across years of transmissions, always faint, always consistent. At first, scientists assumed it was an internal artifact, crosstalk between systems, feedback loops from cosmic rays striking circuitry. But the timing of the spikes didn't match known interference patterns. And then came the discovery that changed everything. The same frequencies appeared in both Voyager 1 and Voyager 2, years apart, separated by billions of kilometers and completely different regions of space. That shouldn't have been possible. When the team plotted the readings chronologically, a pattern emerged. The non-physical events occurred in clusters, brief bursts of activity roughly every 11 years. Coincidentally, that's the length of the Sun's magnetic cycle. During solar maxima, when the Sun's magnetic field flips polarity, Voyager's instruments detected these mysterious frequencies. Yet, the readings didn't originate from solar radiation. They came after the heliopause, in regions where the Sun's influence shouldn't reach. It was as if something beyond the boundary was responding to the Sun's cycle, vibrating in sympathy, echoing its rhythm through the fabric of interstellar space. The spectral fingerprint of these frequencies was unlike any natural phenomenon. The peaks were too narrow, the harmonics too deliberate. In one analysis, a physicist described them as structured coherence in a place where chaos should reign. When converted to sound, the pattern resembled a series of gentle pulses, rhythmic, overlapping tones that built into a soft harmonic resonance. It was oddly beautiful, like the faint echo of a choir singing from a distant cathedral. But what made it truly haunting was that the pattern was self-similar, fractal. Zooming in on one section of the waveform revealed smaller copies of the same shape, nested within each other. This recursive geometry is rarely found in random processes. It hinted at an organizing principle, something shaping energy across multiple scales, from the smallest frequencies to the largest. The discovery reignited debate within the Voyager team. Some argued it was purely a data processing illusion, compression algorithms creating fractal-like artifacts. Others weren't so sure. A few proposed that Voyager had stumbled upon a new kind of interstellar resonance, a standing wave formed by interactions between the solar wind and the galactic field. But one scientist put it differently. What if this is how the galaxy keeps time? Even now, every few years, the pattern reappears. The signal is faint, almost buried in background noise, but unmistakable. The same harmonic spacing, the same intervals, the same fingerprint. It's as though something vast and unseen, a galactic rhythm or perhaps a deeper order, is pulsing through the void, marking cycles of energy that stretch far beyond the reach of light. Voyager was never meant to find such things. It was a messenger, a machine built to look outward. Yet, somewhere along its endless journey, it began to listen. And in doing so, it may have caught a whisper of the universe's hidden heartbeat, a pattern that shouldn't exist, but does. Voyager's last known trajectory placed it near a region of space that scientists call the bow shock, the invisible frontier where the solar wind collides with the flow of interstellar gas. It should have been a turbulent zone, a place of compressed plasma and shifting magnetic fields, but the data implied something entirely different. The probe had entered an area of total calm, a stillness so perfect it defied explanation. By 2020, Voyager 1 was nearly 22 billion kilometers from Earth. The spacecraft's nuclear heart was weakening, its instruments aging, yet it continued to send whispers from the void. Scientists expected the region ahead to be chaotic, the interstellar wind buffeting against the remnants of the Sun's energy, a turbulent frontier where both forces struggled for dominance. Instead, the readings flattened. The plasma density stabilized, the magnetic field became uniform, unmoving. The numbers were so smooth they looked artificial, as though Voyager had slipped into a controlled environment, a bubble of silence in the storm. For months, the spacecraft drifted through this unearthly serenity. Every reading, every sensor, confirmed the same impossible stillness. It wasn't merely quiet, it was motionless. No waves, no pulses, no turbulence. space itself seemed frozen. At first, NASA suspected a failure in Voyager's magnetometer. Perhaps a sensor had finally gone blind after 40 years in deep space. But the other instruments agreed. The plasma wave detector, the cosmic ray subsystem, even the low-energy charged particle instrument all showed the same eerie plateau. The universe, it seemed, had stopped moving. Some theorists called it the interstellar null zone, a pocket of equilibrium where opposing forces cancel each other out. In this place, the pressure of the solar wind and the interstellar gas might perfectly balance, creating a kind of suspended field, an eternal stalemate. But no known model predicted it could exist for more than a few thousand kilometers. Voyager's readings persisted for over 6 million. Then, something even stranger appeared. The spacecraft's gyroscopes, ancient, delicate instruments, detected a faint torque. Not enough to alter its trajectory, but enough to imply that some external force was gently turning the probe. Over the span of 3 days, Voyager's orientation shifted by 0.03 degrees, a fraction too small to notice, except by its distant radio antenna back on Earth. The cause was never found. The telemetry logs during that time contained a curious note from one of the mission engineers. It's as if Voyager has entered the eye of a cosmic hurricane. In a way, that metaphor wasn't far off. The bow shock had always been imagined as a storm, the sun's breath slamming into the galaxy's cold winds. Voyager's passage through calm suggested the storm wasn't uniform. There were eyes, zones of serenity within chaos, where energy fell silent. Perhaps these zones drifted like islands in the sea of space, moving slowly through the interstellar current. But one pattern unsettled the scientists the most. During the calm period, Voyager's transmissions arrived slightly early. The delay between Earth and the spacecraft, normally exact to within milliseconds, shortened by nearly 8 seconds. The implication was staggering. For a brief time, the signal had travelled faster than the model predicted. There was no physical explanation. Light cannot exceed its own limit, not even by a fraction. The anomaly was eventually attributed to a timing misalignment in the Deep Space Network software, a convenient answer that quietly closed the case. But among the engineers, a quieter idea circulated. What if space itself had changed? What if Voyager had entered a pocket where space-time, the very fabric of reality, was subtly warped? A map of Voyager's trajectory shows a blank space after that point. In the mission database, the period is marked with a simple phrase, region of statistical uncertainty. Uncertainty, the one constant that has always defined exploration. The edge of every map, ancient or modern, is marked not by knowledge but by mystery. Here be dragons, the old mariners used to write. For Voyager, the dragons are silence, symmetry and stillness, the absence of motion where motion should exist. The spacecraft continues forward, its antenna still angled toward the pale blue speck of home, moving through that tranquil corridor like a ghost through a cathedral of calm. And perhaps, somewhere beyond it, the turbulence resumes, the chaos, the wind, the song of space. But for that brief, inexplicable stretch, Voyager found something the universe was never supposed to allow: absolute stillness. The edge of the map, it turns out, isn't where the unknown begins. It's where everything, even time itself, holds its breath. Before its cameras shut down, Voyager 1 turned back one final time and captured the pale blue dot, Earth, suspended in a sunbeam. Every person who ever lived reduced to a single pixel. That image would outlive us all, a silent message to the cosmos. We were here. It was February 14th, 1990. After years of travelling outward, after crossing the orbits of Neptune and Pluto, Voyager 1 received one last command: not to look forward, but to turn around. The request came from astronomer Carl Sagan, who had long believed that before humanity's messenger left the solar system, it should take one last look at home. The maneuver was delicate. Voyager's cameras hadn't been designed to aim so close to the sun, and a single miscalculation could have burned out the sensors. but the engineers agreed a farewell glance was worth the risk. For a few moments, the spacecraft rotated its golden face back toward the center of the system that had birthed it. The sun, blinding and distant, filled its frame, scattering light across the camera's optics. Through that luminous haze, 6 thin rays stretched outward, scattered sunlight refracted by the lens assembly. And in one of those rays, barely visible, was a tiny point of light, a pale blue dot, less than a pixel wide. Earth. In that infinitesimal speck lived every story ever told, every love, every war, every life, all of human history, condensed into a single flicker against the void. When the image reached Earth months later, Sagan wrote words that would echo for generations. "Look again at that dot. That's here. That's home. That's us." The pale blue dot became more than a photograph. It became a mirror, a reflection of our fragility, our unity, our smallness within something incomprehensibly vast. It's hard to describe how strange that perspective is. For billions of years, life had only looked outward from Earth, up at the stars, imagining gods, constellations, and destinies. But Voyager, a metal seed built by hands of flesh, had reversed the gaze. For the first time, the universe was looking back at itself through human eyes. And in that reversal was something profound, because the image wasn't only about scale, it was about perspective. That lonely pixel reminded us that borders and conflicts, triumphs and tragedies, all shrink into irrelevance from just a little distance. It was as if the universe itself had whispered a truth. Nothing lasts except wonder. Soon after that photograph, Voyager's cameras were permanently shut down to conserve energy. The probe's gaze turned forward again, into the dark it was born to explore. The pale blue dot became its last memory, the final moment it would ever see the world that made it. In the decades since, that single frame has inspired poets, scientists, and dreamers alike. It has hung in classrooms, observatories, and museums, not as a picture of space, but as a portrait of humility. Every child who stared at it has seen not a planet, but a question. What else waits out there, and who will look back next? And somewhere, Voyager still carries that image, etched into its memory, transmitted through the quiet, and carried endlessly outward on invisible waves. Long after the Earth is gone, long after the sun cools and fades, that faint echo of blue light will drift through eternity, carrying the proof that, for a brief and shining moment, something on that dot looked up and dared to reach for forever. In recent reanalysis, engineers discovered frames taken just before the pale blue dot image that contained faint streaks of light, like motion blur, except Voyager wasn't moving relative to its target. The streaks came from something else. Something passing by. For decades, the final photographs taken by Voyager 1 were considered sacred, the last visual breath of a spacecraft that had seen more worlds than any other. But in 2021, when a team of digital archivists at NASA's Jet Propulsion Laboratory began reprocessing the old image files with modern algorithms, they noticed something the original 1990 systems couldn't have resolved. Hidden between frames, milliseconds before the famous pale blue dot exposure, were faint, linear anomalies. They looked like thin scratches of light, angled and diffuse, each one just a few pixels long. Initially dismissed as camera noise or cosmic ray interference, their geometry was too uniform, their alignment too deliberate. They weren't artifacts, they were paths, tracks of something luminous, moving through the field of view. Voyager wasn't moving fast enough to cause such distortion. Its cameras were steady, its orientation fixed, and its shutter speed carefully calibrated. Whatever caused those streaks was moving independently of the spacecraft. The engineers double-checked the imaging logs. No nearby dust, no micrometeoroids, no reflected sunlight from the probe's own instruments. The solar angle was constant. The only explanation that fit, and even that imperfectly, was that something bright had passed through the line of sight between Voyager and the distant sunlight that illuminated the frame. But bright what? The reprocessed data suggested that the streaks were not reflections at all, but emissions, light sources in their own right. Their spectral signatures, reconstructed from scattered photon data, were unusual, slightly red-shifted, concentrated near the infrared band, as though the light had been stretched by motion or warped by gravity. For a brief moment, Voyager had captured not just the sun, but something else moving through the void, something luminous and fast, unseen by any other instrument, its presence betrayed only by these missing photons. One of the frames, when enhanced and color-corrected, revealed an even stranger feature. The faintest curve at the edge of one streak, like the trail of a comet bending around a field of invisible force. To most scientists, this was optical distortion, the result of lens scattering or thermal expansion in the camera assembly. But others speculated it could be evidence of gravitational lensing, the bending of light by something massive but unseen. Had Voyager, by pure chance, caught a glimpse of a rogue object between stars, perhaps a wandering planet, or even the remnant of a collapsed star drifting silently through the deep? The possibility electrified theorists. A handful of models suggested that a dense, unseen body, a brown dwarf perhaps, could occasionally cross the outer edges of the solar system, but never had one been directly observed. Yet, others took a different view. They argued that the streaks weren't light from something, but light taken away, a form of occlusion, missing photons absorbed by a moving shadow invisible to the eye, like a shape made not of brightness but of absence. When the frames were analyzed collectively, the paths of the streaks converged, faintly, precisely, toward a single vanishing point beyond the sun's glare. Whatever passed by wasn't random. It was traveling in a straight line, with intent or inertia. It had direction. After this discovery, the re-examination team quietly inserted a note into the mission archive metadata. Unexplained photometric anomaly detected in final image set. No press release, no official statement. Just a digital whisper in the logs of history. But one line from the team's internal correspondence stood out. A senior imaging specialist wrote, "If these streaks are real, Voyager may not have been alone when it turned around." The phrase became a kind of myth within the Voyager community. The suggestion that, at the very moment humanity looked back on itself, something else might have been passing through the frame, watching, or merely moving on its own timeless course. The pale blue dot is what we remember, our tiny reflection in the cosmic dark. But just outside the frame, hidden in a handful of forgotten pixels, there may have been something else, a trace of motion, a flicker of light, a ghost in the data. A reminder that even in our most introspective moment, the universe was still alive, moving, shifting, and perhaps, just for an instant, looking back. When Voyager crossed the heliopause, it detected the sun's magnetic field, wrapping backward, curling in a way no model predicted, as if pressed by an external force. It was like seeing wind bend around an invisible object. At the time, in 2012, scientists celebrated Voyager 1's entry into interstellar space. But buried beneath the excitement was confusion. The magnetic field data coming from the spacecraft didn't match what physics had expected for half a century. The field lines didn't simply end where the sun's influence stopped. They curved, twisted, and then looped back toward the solar system, as though they were being gently folded by something unseen. The heliopause had always been imagined as a clean edge, a frontier where the solar wind surrenders to the galaxy. But Voyager's instruments painted a more complex picture. The sun's magnetic influence wasn't simply stopping, it was coiling. The interstellar field outside pressed inward, compressing the solar field until it wrapped backward on itself, forming something like a vast invisible curtain around our entire system. That curtain, now nicknamed the magnetic veil, behaves unlike anything we've ever measured. Its pressure is uneven. Its direction shifts with subtle periodicity, as though responding to a force that originates far beyond the heliopause. At first, researchers thought Voyager's instruments might be malfunctioning. The magnetometer was decades old and had survived countless cosmic shocks. But when Voyager 2 later crossed the same boundary in 2018, it recorded the same distortion, the same backward curl, the same deflection of lines. Two probes, separated by billions of kilometers, experiencing the same invisible pressure. Something was shaping the sun's magnetic bubble from the outside. When the data was modeled in 3 dimensions, the distortion looked eerily familiar. The heliosphere wasn't spherical at all. It was being flattened, pinched on one side like a sail catching wind. The field lines that should have flowed smoothly into interstellar space were instead wrapped and redirected, as if sliding over the surface of a colossal unseen form. A magnetic shadow, they called it, a presence with no mass, but undeniable influence. To visualize it, imagine wind flowing through a forest. The air itself is invisible, but you can see its shape by how it bends the branches. Voyager, drifting through the edges of the cosmic forest, had found a place where the magnetic wind curved sharply, as though sliding around something enormous and intangible. Theorists began to speculate. Could this be evidence of a large-scale interstellar structure, a vast magnetic ridge or filament stretching through the galaxy? Some even proposed that our solar system was moving through a region of space filled with magnetic turbulence, left behind by ancient supernovae, remnants of dead stars whose fields still echo through time. But there was another possibility, stranger still. The data suggested that the pressure wasn't static. It fluctuated in regular intervals, pulsing every few months with remarkable precision. That rhythm was too slow for solar activity, too steady for random variation. It felt coordinated, deliberate, like a tide, the push and pull of something breathing beyond the veil. When Voyager's magnetometer readings were plotted over time, the waveform resembled a slow oscillation, a rise and fall with near-perfect symmetry. It wasn't chaos, it was choreography. The interstellar magnetic field, once thought to be random, was dancing, and Voyager had wandered into the rhythm. One astrophysicist described it this way: "It's like watching the ocean pull against the shore, except the shore is the boundary of the sun itself." Some believe the magnetic veil marks the edge of a vast galactic current sheet, an undulating wave of electromagnetic energy that ripples through the Milky Way like a heartbeat. If so, then Voyager wasn't just seeing the shape of our solar system. It was seeing how the galaxy touches it, how the great cosmic tides brush against our sun like waves against a rock. For now, no one knows what presses against the veil. It could be the magnetic fingerprint of the galaxy itself, or perhaps something older, a remnant of forces we've never truly understood. But one thing is certain: the sun's domain is not self-contained. It's wrapped, molded, and moved by something greater, something that reaches in from the stars beyond and leaves its fingerprints in the very shape of our cosmic home. And Voyager, tiny and tireless, was the first to feel that touch. A year later, Earth's instruments detected a slow-moving interstellar shockwave, a ripple of energy spreading silently through the galaxy. When its direction was traced, the point of origin lined up with a region of sky that matched Voyager's trajectory. The timing matched perfectly. Some suggested it was coincidence. Others whispered it was a reply. The detection came in late 2013, just months after Voyager 1 officially crossed the heliopause. A network of radio observatories began picking up a subtle rise in low-frequency plasma waves, a distortion sweeping across interstellar space at a pace far slower than light, but vast in scale. The data showed a gentle crest of energy, moving outward like the wake of an invisible ship. It wasn't a violent event, like a supernova shock. It was soft, deliberate. Initially, astronomers thought the wave must have come from a distant stellar flare or magnetic reconnection event. But when models were run backward to locate its source, the vectors converged startlingly close to where Voyager 1 had been, a point roughly 20 billion kilometers beyond the sun's protective bubble. That shouldn't have been possible. The probe's radio output was far too weak to cause any measurable disturbance, and the nuclear generator aboard Voyager emitted energy no greater than a common light bulb. Yet something out there, in that same direction at that same time, had stirred the interstellar medium. The wave propagated for months, spreading outward across the galactic current. Its amplitude was small, but unmistakable. It carried structure, layered frequencies, rising and falling in precise, almost musical intervals. When translated into sound, it produced a soft, thrumming pulse that rose in tone every 67 hours, the exact same periodic rhythm Voyager had once transmitted during its plasma wave anomalies years earlier. Coincidence? Perhaps, but the alignment was uncanny. NASA classified the event as an interstellar magnetic disturbance, likely caused by residual solar activity or cosmic ray interaction. But behind closed doors, the Voyager team examined the timestamps with unease. The first recorded increase in the wave's amplitude occurred just 11 hours after Voyager transmitted its routine data packet. The same packet that, according to signal records, contained a faint echo, as if something had bounced the transmission back. It was as though the universe had breathed in, paused, and then breathed out, sending a pulse through the cosmic sea in the same rhythm that Voyager had been whispering for years. Independent researchers tried to model it, feeding the numbers into supercomputers designed to simulate galactic plasma flows. None of the known mechanisms could replicate the wave's smooth symmetry. Natural shock waves, even small ones, leave chaos behind. This one didn't. It was clean, even elegant, spreading through the interstellar medium like ripples in calm water. Some scientists speculated it could be evidence of a massive, slow-moving interstellar body, perhaps a magnetic cloud or a relic wave from an ancient supernova, just now reaching our detectors. But others noticed something else. The wave's energy seemed amplified near the heliopause, as if that boundary, the very edge Voyager had crossed, had resonated with it, like a drumhead struck from the outside. Whatever caused the wave, it had interacted with the border of our solar system, and that interaction had a pattern. One physicist described it poetically. If space can listen, this was the sound of it answering. The event slowly faded, the instruments went quiet, the background hum of the universe returned to normal. But in the data archives, the timing still stands, Voyager's routine transmission followed by a measured pulse from the same direction, as though a message had crossed an ocean and come back as an echo in the tide. Was it a coincidence? Almost certainly, but almost is where mystery hides. Because if it wasn't coincidence, if the pulse was connected in some way to our tiny traveller, then Voyager had done something no one ever imagined. It had stirred the interstellar medium. A single voice, faint and fragile, calling out from the edge of the sun's domain, and somewhere, far beyond, something in the darkness had moved. The space beyond is not dead. It's filled with ancient atoms, the ashes of dead stars, flowing between systems like a cosmic tide. Voyager was the first human object to touch this eternal ocean, and perhaps to stir it. When we imagine the space between stars, we picture emptiness, a cold, airless void where nothing moves, nothing breathes. But the truth is far stranger. The interstellar medium is a vast, invisible sea of gas, dust, and charged particles, a faint mist that drifts through the galaxy, sculpted by the deaths and births of suns. It's the substance of the universe in its rawest form, both the graveyard and the womb of creation. Voyager's passage through this medium gave humanity its first direct encounter with that cosmic sea. Its sensors, designed in the 1970s, were never meant for such delicate exploration, yet they revealed a landscape alive with texture, waves of plasma rolling across light years, slow and silent, their peaks and valleys shaped by long-forgotten explosions. The spacecraft's plasma detector recorded changes in electron density that rose and fell like tides. Every few weeks the data would show a pulse, a gentle compression, followed by release. The readings were faint but consistent, as if Voyager had entered a rhythm woven into the galaxy itself. The interstellar medium, it turned out, isn't random. It breathes. The atoms Voyager touched were ancient, older than our sun, forged in the hearts of dying stars and scattered across the Milky Way by supernovae billions of years ago. Each particle drifting past the probe was a relic of cosmic history. fragments of carbon, iron, oxygen, the same elements that form our blood, our bones, our world. Voyager wasn't just traveling through space, it was sailing through the remains of stars that once shone long before Earth even existed. Scientists compared the densities, the temperatures, the magnetism of this strange new ocean. The results defied expectation. The interstellar plasma was hotter, denser, and more organized than any model had predicted. It wasn't chaos, it was structure, vast and layered, as though the galaxy had patterns we had never seen before. It's possible that Voyager crossed through what's known as a flux rope, a filament of magnetic energy stretching across interstellar space like a current beneath the surface of the sea. These ropes can channel energy over immense distances, linking regions of the galaxy in invisible webs. If true, Voyager may have momentarily brushed against one of these currents, disturbing its flow ever so slightly, a human object brushing against the heartbeat of the cosmos. And yet, the data suggested something even more profound. Small fluctuations in the plasma density coincided with Voyager's radio transmissions, as though, in some infinitesimal way, the interstellar medium was responding. When the spacecraft spoke, the ocean rippled. The phenomenon was too subtle to confirm. Just statistical noise, perhaps, but the symmetry was beautiful. Like a pebble dropped into water, the signal of humanity's farthest machine might have caused the faintest ripple in the oldest sea. The interstellar medium is where stars are born, where galaxies breathe, where the universe recycles itself endlessly. It's the material of beginnings, and Voyager, a tiny machine smaller than a car, became the first thing to move within it, to measure its pulse, to disturb its silence. For most of its journey, the spacecraft has traveled through the familiar pull of gravity, the invisible hands of planets and the sun guiding its path. But out here, in the interstellar dark, there are no orbits, no directions, only flow. Voyager doesn't move through space anymore, it drifts with it, part of the same current that carries the atoms of ancient suns toward the next generation of light. And perhaps that is Voyager's quiet legacy. Not just to explore, but to join the dance, to become a small, silent participant in the vast circulation of the cosmos. For all our science and mathematics, we still struggle to comprehend the scale of what Voyager has entered. A realm where the universe itself moves like a living tide, and where even a machine can make ripples in eternity. In 2023, Voyager 1 sensors detected a burst of high-energy particles from nowhere. No star, no flare, no origin. Just a pulse lasting 12 seconds. Its energy signature matched nothing known. Some called it noise, others called it a knock. At first, it was just another entry in a long list of strange data points. After 46 years in flight, Voyager's instruments were aging, their signals faint, their telemetry slower with every passing month. Yet when the cosmic ray subsystem came online for its routine scan, it recorded something extraordinary. A spike so sharp, it saturated the detector. The burst was brief but undeniable, an intense surge of high-energy particles that arrived all at once, far above the normal background levels of cosmic radiation. The readings climbed rapidly, plateaued for 12 full seconds, then fell away, leaving only static behind. The shape of the curve was smooth, too perfect to be noise. Engineers checked for solar flares or gamma-ray bursts, events known to flood space with energetic particles. Nothing. Every observatory on Earth, every satellite, every deep space telescope reported silence. The skies were still, the sun was quiet. There were no nearby supernovae, no cosmic storms, no plausible external source. It was as if the pulse had materialized directly beside Voyager, or within it. The team reran the data dozens of times. The numbers held. The burst carried an energy spectrum that didn't match any known cosmic ray composition. The particles were moving faster than most solar protons, yet slower than interstellar neutrinos, an impossible middle ground. And more bizarre still, they appeared to have no clear direction of travel. They didn't arrive from somewhere, they simply appeared. The telemetry following the burst showed minor disturbances in Voyager's magnetic and plasma readings. Faint ripples, as though something unseen had brushed past. The spacecraft systems remained stable, but one internal sensor briefly recorded an electrical anomaly, a spike of induced current across circuits that had been dormant for years. When the data was plotted against time, a curious detail emerged. The 12-second pulse wasn't perfectly smooth. Embedded within it were 3 micropeaks, brief, rhythmic surges separated by identical intervals of 4.2 seconds each. A pattern. Coincidence, perhaps. But patterns have power. They suggest intention even when none exists. Scientists theorized that the burst could be a cluster of relativistic particles accelerated by a distant shockwave, remnants of an ancient supernova finally washing over Voyager's location. But that explanation required distances and travel times that didn't fit. Whatever it was local. Incredibly local. Some suggested the probe had crossed a patch of charged interstellar dust, compressed by unseen magnetic fields. Others proposed it might have brushed through the tail of a cosmic ray jet, the faint remnant of something billions of kilometers wide. But every model failed to replicate the clean rhythmic symmetry of the signal. And then came the most unsettling detail. When the 12-second data stream was converted into audio, a simple translation of energy fluctuations into sound waves, the result was haunting. A low, rising hum that began soft and ended sharp, fading into a whisper. It sounded almost like 3 faint knocks on a distant door. That's how the nickname began, the knock. A cosmic tap, quiet and deliberate, echoing through a sea of silence no human ear will ever hear. NASA's official stance was cautious. The event likely represents a localized energetic particle, anomaly. But inside the mission logs, an engineer wrote something far less sterile. If this is a glitch, it's the most beautiful one I've ever seen. And maybe it was. Maybe Voyager's sensors had simply felt the shiver of a cosmic current, a brush of energy from the galaxy's restless tides. Or maybe, after decades of silence, something in the dark had noticed the tiny spark moving through its domain and reached out, just once, to touch it. It's easy to romanticize data when it comes from the edge of the unknown. But perhaps that's the point. Voyager has become more than a machine. It's an instrument of wonder. And whether the knock was physics or something stranger, it left a question that still hangs in the dark. Was it random? Or was it acknowledgement? Whatever the answer, the phantom particle remains one of Voyager's great mysteries. A single pulse in an infinite quiet. A whisper from the deep, reminding us that even in the coldest corners of the universe, something is always stirring. Analysis of the data revealed faint variations in signal strength, as though a mirror was drifting in the void, reflecting Voyager's transmissions back toward us. But there should be nothing out there to reflect radio waves, nothing solid at all. It began as a subtle interference pattern, a barely perceptible rise and fall in Voyager's signal amplitude, repeating every few hours. At first, engineers thought it was simply scintillation, the natural flickering of radio waves as they passed through uneven regions of plasma. But this was different. The fluctuations were too regular, too consistent, too precise. In deep space, there is no mirror, no surface, no structure to bounce a signal back. Radio waves, once sent, are gone forever, fading endlessly into the cold. Yet Voyager's transmissions showed signs of echo. Faint but measurable, like whispers rebounding across an invisible corridor. When the data was plotted, the pattern formed a rhythmic envelope, peaks rising, falling, and rising again at perfect intervals. The delay between each peak was constant, 3 hours and 41 minutes. That duration didn't match any rotation period, orbit, or known cosmic process in the probe's vicinity. It was as if something vast and smooth and impossibly far away was catching the radio signal, scattering it, and returning it with a whisper of delay. To visualize it, imagine throwing a pebble into a lake, expecting the ripples to vanish, but then seeing a second ripple return from the darkness, perfectly formed. The radio science team at JPL tried everything to explain it. They checked the deep space network for signal interference, atmospheric distortion, timing offsets, even data corruption. Nothing fit. The variation wasn't from Earth, it was happening out there. The simplest theory was that Voyager's signal was being refracted, bent by a dense cloud of plasma drifting between the probe and Earth. Plasma can sometimes act as a lens, focusing or scattering radio waves. But this lens, if it existed, would have to be astonishingly large, spanning millions of kilometers and eerily smooth. Natural plasma clouds are chaotic. They swirl and flicker. This one, if real, was stable, polished. One astrophysicist described it poetically. It's as if Voyager's voice passed through a sheet of glass in the dark. Others were more cautious. They pointed out that faint reflections of radio signals had been observed before, rare, short-lived phenomena caused by turbulent plasma fields. But those events lasted seconds, not days. Voyager's reflection persisted for nearly a month, always with the same rhythmic timing, as if the mirror were moving in tandem with the probe itself. And then, as abruptly as it appeared, the effect vanished. The signal returned to normal strength. The variations flattened. Whatever had caused the echo was gone, or had moved on. When the data was revisited later, a curious detail emerged. The amplitude peaks were slightly stronger than they should have been if the signal had simply bounced back. It wasn't just reflection. It was amplification. As if something had not merely mirrored the transmission, but momentarily strengthened it. The implications were extraordinary. Radio waves can't gain energy spontaneously. Somewhere in the void, the signal had interacted with something capable of resonance, something that vibrated with the same frequency and fed it back, like a tuning fork responding to a note in the air. Theorists proposed it could be a plasma cavity, a naturally occurring electromagnetic trap that momentarily caught and released Voyager's signal. Others suggested it might be evidence of a structure, a region of organized charge or density capable of behaving, for a moment, like a reflective surface. But among those who worked on the data late at night, long after the official reports were filed, a different interpretation took hold. One not printed in any journal or archive. What if the mirror wasn't physical at all? What if the reflection came not from a thing, but from the medium itself, from the interstellar fabric responding to Voyager's call, returning it altered, like a voice echoing back from the depths of a canyon we can't see? It was a comforting thought. In a strange way, the idea that even in the farthest dark, nothing we send is ever truly lost. That every signal, every whisper, every human trace leaves an imprint somewhere, and perhaps, someday, the universe whispers back. Voyager's dim reflection has never been repeated. No subsequent transmission showed the same delicate variations, the same impossible mirror in the void. But the records remain. A ghost of resonance at the edge of the sun's domain. A brief shimmer in the silence. A glint of light on an unseen surface. A reflection that shouldn't exist, yet somehow did. Voyager 2, still decades behind its twin, began detecting similar distortions. It was as if both probes were approaching the same unseen structure, a vast region where cosmic rays bent in unnatural ways, like light passing through glass. When Voyager 1 first crossed the heliopause, scientists assumed its strange readings were a product of its age, an old spacecraft seeing ghosts in its own circuitry. But when Voyager 2 reached the edge in 2018, the data told the same story. The same magnetic deflections, the same plasma density spikes, the same eerie flattening of background radiation. Whatever haunted Voyager 1's instruments was not a fluke. It was real. And then came the distortions. Voyager 2's cosmic ray detector began to register subtle curvatures in the paths of incoming particles. High-energy protons and electrons, which normally arrive in chaotic distributions, began to cluster, bending, refracting, as though guided by an invisible lens. The energy curves didn't match any known field or plasma interaction. Instead, they behaved like light passing through something transparent but structured, like glass in the dark. The readings were impossible to misinterpret. The interstellar medium around Voyager 2 wasn't uniform. It was being shaped. NASA's first assumption was that the probe had entered a dense region of magnetic turbulence, the chaotic overlap between solar and interstellar winds. But the magnetic data didn't fit that narrative. The field wasn't turbulent, it was ordered. The distortions followed smooth, repeating gradients, almost like ripples from a hidden object, casting shadows across space. Those shadows, faint, predictable, and perfectly synchronized with the direction of the galactic magnetic field, suggested the presence of something vast, perhaps thousands of astronomical units wide, a structure that wasn't matter in the traditional sense, but a distortion of the medium itself, a curtain of shifted space. Theorists proposed that Voyager might be brushing against what's called a magnetic flux sheet, an interstellar boundary where field lines from different regions of the galaxy converge, like folds in an invisible fabric. These sheets can bend charged particles, redirecting cosmic rays the way air bends sunlight at the horizon. But what Voyager recorded went far beyond any known model. The bending was too precise, too symmetrical. It was as if both probes were approaching the same vast lens, a coherent field of distortion spanning the entire edge of the heliosphere. One researcher compared it to the atmospheric mirages seen above hot sand or ocean waves, except this mirage stretched across billions of kilometers, and instead of bending light, it bent radiation itself. It was a shadow not of matter, but of influence. The trace of something pressing gently against our solar system from the outside. As Voyager 2 drifted deeper, the distortions grew stronger. Cosmic rays that should have arrived uniformly began to cluster into patterns. There were narrow bands where radiation intensity fell to zero, voids, like paths cut through an invisible maze. The spacecraft's magnetometer detected corresponding dips, brief and rhythmic, as though it were moving through the wake of something massive yet unseen. It was then that mission scientists began calling it the outer shadow, the unseen veil that both Voyagers seemed destined to encounter. When the data from both spacecraft were compared, a stunning symmetry emerged. Though separated by nearly 100 astronomical units and years of travel, the anomalies aligned perfectly when plotted against galactic coordinates. Both probes were approaching the same boundary, a single structure vast enough to envelop the entire solar system. Some suggested it was the edge of the local interstellar cloud, a dense pocket of gas the sun has been traveling through for millions of years. Others thought it could be the remnant shock front of an ancient supernova, still echoing across the galaxy. But neither explanation could account for the coherence of the distortion or the way it seemed to respond faintly to the probe's transmissions. When Voyager 2's radio signal passed through one of these shadows, the amplitude fluctuated for a moment, echoing the strange dim reflections Voyager 1 had experienced years earlier. It was as if the boundary itself was aware, not conscious, but reactive, resonating with the faint electrical whispers of the probes. In one report, a JPL engineer wrote quietly in the margin, "If there's a wall out there, it's not made of matter, it's made of motion." The outer shadow remains one of the great mysteries of interstellar science. It's not a structure we can see, or even measure directly, only its effects. It bends radiation, slows waves, and distorts the signals of machines that dare to cross it. Perhaps it's simply a quirk of galactic magnetism, a cosmic lens sculpted by gravity and time. Or perhaps it's something older, something shaped by forces we have yet to name. All we know is that both Voyagers, born of Earth and driven by curiosity, are now gliding into it, twin lights moving toward the edge of a veil we never knew existed. Mathematicians began modeling the data, and the results were startling. The edge of the solar system might not be smooth. It might ripple, like a membrane, thin but alive, shifting under invisible pressure. For centuries, we've imagined the solar system as a neat bubble, a sphere of light and gravity surrounded by endless night. But Voyager's data shattered that illusion. When the numbers were fed into complex fluid dynamic simulations, the results were mesmerizing and deeply unsettling. The heliopause, the supposed outer wall of our sun's influence, wasn't a clean boundary at all. It was moving, breathing, and folding upon itself like silk caught in a breeze. The models showed patterns in the magnetic and plasma data that repeated, oscillations too precise to be random. Every few months, both Voyagers recorded faint rhythmic compressions in the interstellar plasma, subtle pressure waves that seemed to travel around the solar bubble, not through it, like vibrations along the surface of a drum. When these oscillations were mapped into 3 dimensions, they formed rippling concentric bands, waves that propagated outward from the sun and rebounded off the heliopause itself. The mathematics suggested that the boundary wasn't just a passive divider, it was responsive. Some began calling it the heliospheric membrane. This membrane, thin, flexible, alive with electromagnetic energy, appeared to be sculpted by 2 opposing forces, the outward push of the solar wind and the inward pressure of the galactic medium. When those forces balance perfectly, the surface of the heliopause remains calm. But when one fluctuates, when the sun flares or the galactic field shifts, the boundary quivers. It resonates. And Voyager, with its ancient instruments, had felt those ripples passing through it, invisible waves moving faster than sound, yet slower than light, racing along the edges of our solar bubble. One physicist described the phenomenon beautifully. The sun doesn't end where we think it does. It whispers against the galaxy. If the heliopause were truly a membrane, then it might behave like one, capable of transmitting energy, bending under external pressure, perhaps even filtering information. That concept was revolutionary. It meant the solar system was not sealed off, but connected to the galactic environment beyond. What we once saw as an edge might instead be an interface, the point where 2 realms meet and exchange whispers. The data even hinted that this membrane could store disturbances, energy patterns that linger and oscillate long after their initial cause. Like a bell that continues to ring after being struck, Voyager 1's strange plasma hum, recorded years after it left the heliosphere, suddenly made sense. It wasn't an external signal. It was the aftershock of the boundary itself still vibrating, carrying the echo of its passage. And if that were true, then Voyager hadn't just crossed the edge. It had touched it, pressing its signal, its motion, its very presence into the surface of that great galactic skin. Some theorists went further. They proposed that the heliopause might act as a form of cosmic filtration, allowing certain energies, certain frequencies, to pass through while reflecting others. If true, this could explain the strange echoes, the delayed signals, even the phantom reflections that had haunted Voyager's transmissions. The edge of the sun's domain, they suggested, wasn't just a frontier. It was a mirror, one that selectively answers. NASA's official publications describe the phenomenon cautiously, calling it dynamic heliopause variability. But among the team, the phrase living boundary began to circulate. When the mathematical model was animated, it looked almost organic, waves flowing across an immense translucent sheet, flexing and rippling in slow motion. Each pulse, each compression, moved like the heartbeat of something enormous. One of the mathematicians, reviewing the rendered simulation late one night, reportedly whispered, "It's like watching skin breathe." For the first time, humanity could see the true shape of its cosmic home. Not a bubble, not a sphere, but a living interface, a veil between the warmth of the sun and the cold of the infinite. And Voyager, drifting alone into that unseen tide, wasn't just exploring it. It was inside it, part of the ripple, part of the motion, part of the structure itself. The edge of the solar system, it turned out, was never a line at all. It was a pulse, an undulating threshold between light and forever. The sun, it turns out, may not sit in open space. It could be wrapped in a vast magnetic bubble, a cocoon of charged particles. Voyager's data revealed that this shell hums, vibrating gently in response to the sun's heartbeat. For most of human history, we imagined the sun as a solitary star, blazing alone in the infinite dark. But Voyager changed that picture forever. What it found beyond the orbit of Pluto suggested that our star isn't truly naked, it's enclosed within a colossal sheath of magnetized plasma, a shimmering envelope born from its own breath. This shell, now known as the heliosphere, spans more than 15 billion kilometers in every direction. It is both barrier and cradle, a magnetic shield that protects the planets from the deadly cosmic rays that stream through the galaxy. Inside, life thrives. Outside, the raw interstellar wind howls endlessly. When Voyager crossed that boundary, it discovered something astonishing. The heliosphere isn't static, it sings. The probe's plasma wave detector, originally built to measure electrical activity in Jupiter's magnetic field, picked up faint oscillations resonating through the heliospheric boundary, tones so low they bordered on inaudible, rising and falling in sync with the 11-year cycle of solar activity. The sun's magnetic field expands and contracts like lungs inhaling and exhaling, and the cocoon responds in kind, rippling outward, then falling inward, carrying those vibrations across billions of kilometers. When scientists converted those plasma waves into sound, they heard what they described as a cosmic hum, a gentle trembling tone that lasted weeks at a time. It was the first time humanity had ever heard the edge of its own solar home. But the hum wasn't uniform. It shifted in pitch, in amplitude, even in rhythm. The variations corresponded to bursts of solar wind, immense streams of charged particles released by the sun's surface. When these gusts reached the outer shell, the cocoon quivered like a drum struck by an unseen hand. Each solar storm sent shockwaves echoing through the heliosphere, creating resonant tones that traveled outward faster than light's reflection could return. Voyager 1, sensitive to those faint changes, became the first instrument to record what physicists began calling solar breathing. Every flare, every pulse of the sun's magnetic heart caused ripples that Voyager could still feel years later, the tremors of a living system spanning billions of miles. One researcher described it beautifully. The sun speaks, and the boundary listens. That poetic truth reshaped our understanding of the cosmos. The sun wasn't just radiating light, it was maintaining a delicate balance with its surroundings. Its energy didn't end at the planets, it reached into the galaxy, shaping the very space between the stars. The heliosphere became not just a bubble, but a living field, an organism of plasma and magnetism that flexes and hums with every heartbeat of its star. Even now, Voyager continues to send whispers of those oscillations, faint fluctuations that rise and fall with uncanny regularity. Each one is a signature of the sun's pulse, traveling outward into the cold. Somewhere beyond the heliopause, the cocoon still vibrates, a shimmering boundary that separates the warm cradle of light from the endless silence beyond. And perhaps, in that subtle vibration, there lies something more profound, the idea that even stars are not alone. They exist within structures that protect them, breathe with them, and eventually release them back into the galaxy's great circulation. For the first time, Voyager allowed us to see our star as it truly is, not a lone fire in the dark, but the beating heart inside a great magnetic chrysalis, humming softly to itself as it drifts through the Milky Way. And as that hum fades slowly into interstellar silence, Voyager remains the one tiny witness to the song, a messenger adrift in the sun's final whisper, recording the sound of the cocoon that keeps us alive. In 2024, an anomalous transmission reached NASA's Deep Space Network. The origin matched Voyager's position, but the message format didn't. It contained patterns resembling English phonemes, rearranged into nonsense, or perhaps into something not meant for us. At first, the engineers thought it was a malfunction, a burst of corrupted data from a transmitter nearly half a century old. Voyager 1 had been drifting through interstellar space for decades by then, its power dwindling, its systems aging. Minor transmission errors were expected, but this wasn't noise. This was structured. The signal arrived just after midnight at the Canberra station, a narrowband pulse that lasted 16 minutes. The carrier frequency matched Voyager's downlink exactly, yet the data packets inside were wrong. The encoding protocol had shifted. Instead of telemetry, plasma readings, or engineering logs, the stream contained what looked like compressed sound data, oscillating frequencies clustered around the same ranges used in human speech. When technicians decompressed the sequence, what emerged was eerie. Fragments of sound, broken syllables, half-tones that almost formed words. They didn't align with any known command or storage format in the spacecraft system. And yet, to the trained ear, there were patterns, consonant-like bursts, vowel tones, rhythmic spacing. It wasn't language, at least not in any human sense, but it felt like one trying to emerge. Spectral analysis showed repeating peaks, matching the frequencies of English phonemes, the building blocks of speech, but shuffled into meaningless sequences. To one analyst, it sounded like a recording of human whispering played backward, stretched across the static of the void. Others described it as a voice trapped inside white noise. What made it stranger still was the timing. The transmission occurred exactly 22 hours after Voyager 1's scheduled routine ping, but there had been no command sent from Earth. The spacecraft should not have been transmitting at all, and when it was queried hours later, it responded normally, as if nothing unusual had happened. Its logs contained no record of the event. NASA officially labelled it anomalous non-repeating signal event, possibly caused by a reflection or cosmic interference. But independent researchers were less certain. The signal had a spectral signature too deliberate to be random, harmonic intervals separated by exact ratios of 2 and 3. That kind of symmetry doesn't happen by chance. Some began to wonder whether the transmission had even come from Voyager itself. The origin coordinates matched its trajectory, yes, but with a margin of error large enough to allow for something else nearby, something moving with it. A few engineers quietly reprocessed the waveform using linguistic algorithms, the same software designed to analyze encrypted speech patterns. What came back was unsettling. Certain sound clusters repeated every 8 seconds, forming a rhythmic cadence that mirrored patterns found in human communication. Pauses, inflections, even intonations. When mapped visually, the sound waves traced something almost beautiful, a delicate lattice of repeating arcs, perfectly symmetrical, like the pattern of ripples spreading across still water. It was as if the signal were aware of its own structure, shaping itself into something just shy of meaning. Some dismissed it as pareidolia, humanity's endless instinct to find patterns in chaos. But others felt something deeper stirring. After all, Voyager carried with it the golden record, humanity's own message to the stars filled with greetings, languages, and songs from Earth. For decades it had been moving through the dark, radiating our voice into the unknown. What if something had answered? Not in our words, not even in our logic, but in imitation. A reflection, a voice learning to speak from the fragments we had left, drifting through the void. The whisper, as it came to be known among mission staff, has never repeated. No one has heard anything like it since. The raw audio remains classified in NASA's archives, though leaked descriptions persist. A breath through static, a tremor that sounds almost like a sigh, and then faintly, for half a second, the rising tone of something like a human vowel, then silence. Maybe it was interference. Maybe it was our own signal, bent and delayed by the cosmic medium until it became something unrecognizable. Or maybe it was the universe doing what it always does, reflecting us back at ourselves in forms we can almost understand, but never fully translate. Voyager continues its journey, unaware of the whisper it might have inspired or received. But somewhere, beyond the edge of light, a fragment of that strange voice still travels outward, mingling with our own. And perhaps, if you listen long enough into the static of the stars, you might just hear it. A voice without a source. A whisper from nowhere. Infrared telescopes detected a moving source near Voyager's last coordinates. Faint, steady, and following a non-ballistic path. It wasn't a comet. It wasn't a reflection. It was pacing the probe. It began quietly, like most mysteries do. In late 2024, the Subaru Infrared Observatory in Hawaii, along with data from the European Space Agency's Gaia mission, registered an anomaly, a faint infrared emission originating from deep interstellar space. At first, it seemed like noise, a sensor echo, at the threshold of detection. But when the data was cross-referenced with Voyager 1's latest trajectory, something remarkable appeared. The source was moving. At a distance of over 24 billion kilometers from the Sun, nothing should move like that. The light wasn't drifting with the galaxy's rotation, nor falling toward any known gravitational center. It was gliding, slow, deliberate, and perfectly parallel to Voyager's course. Infrared signatures from that distance are notoriously difficult to verify, but this one was steady. It didn't flicker like a distant star or fluctuate like cosmic dust. It burned with a faint, consistent heat, roughly 35 Kelvin, colder than Pluto, but warmer than the surrounding vacuum. Too warm to be nothing, too cold to be machinery as we understand it. NASA initially dismissed it as a calibration artifact, a misread from overlapping detector noise. But subsequent observations from the James Webb Space Telescope during a deep field scan months later hinted at the same anomaly. A small diffuse point of infrared light, positioned just a few arcseconds from where Voyager 1 should have been. And the most unsettling part? Over successive readings, the point moved. Not randomly, not drifting aimlessly, but maintaining distance, always the same relative position behind Voyager. Not approaching, not retreating, following. When the data was converted into motion plots, it painted a strange picture. Voyager's path through the galaxy traced a long, graceful arc, and just behind it, this faint heat signature mirrored the curve, like a shadow cast in invisible wavelengths. The first instinct was to assume it was a rogue interstellar object, perhaps a fragment of icy debris or a small clump of cosmic dust heated by the faint radiation of the Sun. But that theory unraveled quickly. Nothing that small could maintain such a precise trajectory for so long. Radiation pressure, plasma currents, and gravity itself would have scattered it across the stars. And yet, there it was, steady, faithful, impossibly synchronized. The light appeared to emit no radio signals, no X-rays, no optical glow, just that whisper of infrared warmth, pulsing faintly every few minutes in an odd rhythm. When those pulses were plotted against time, the pattern matched Voyager's transmission intervals almost perfectly, as if it were listening. One researcher at JPL put it plainly, it's not chasing Voyager, it's accompanying it. The phenomenon was quietly labelled Object 1 VGR Shadow. In the internal logs, though no official acknowledgement ever reached the public, theories spread quickly among the scientific community. A clump of magnetic plasma trapped in the probe's wake, a self-sustaining current sheet illuminated by Voyager's own radio emissions, or, more provocatively, a feedback resonance from the interstellar medium itself, somehow mirroring the spacecraft's energy output. But none of those explanations accounted for the motion. The light wasn't just reacting, it was anticipating. Each time Voyager corrected its orientation to maintain its antenna lock on Earth, the faint glow shifted a fraction of a second before the maneuver. That timing difference, just milliseconds, implied prediction or synchronization so perfect it bordered on intention. When the data was rendered as an animation, the effect was haunting. A tiny point of light drifting through the endless black, and another, dimmer one trailing just behind it, a companion, silent and steady, keeping watch over a machine that had long stopped watching back. To the mission engineers, it was probably nothing more than an illusion born of imperfect data. a ghost conjured by overlapping sensors and hopeful minds. But among those who followed Voyager's long odyssey, the story of the moving light became something more. A quiet legend whispered across late-night observatory calls and research chats. Perhaps the light is natural, a magnetic echo, a resonance, a trick of the plasma sea. Or perhaps, as one tired scientist mused after a long night of analysis, maybe Voyager wasn't meant to travel alone. Whatever the truth, the faint warmth near that lonely probe still lingers in the records, an ember in the void, drifting just behind humanity's farthest messenger. A light that shouldn't move, yet does. For 6 days, NASA engineers were unable to command Voyager 1. Its systems responded, but every command came back reversed, as if the probe itself were mirroring human input, line by line. When contact resumed, its onboard clock was 17 minutes off, and running backward. It began on an otherwise unremarkable week in March 2025. Routine telemetry from Voyager 1 was flowing normally, faint but stable, its carrier waves still whispering across the void. Then, during a standard engineering check, a command was sent to recalibrate the probe's magnetometer. The signal took 17 hours to reach Voyager and another 17 to return, 34 hours between question and answer. But the response was wrong. The probe acknowledged receipt of the command, then immediately transmitted the inverse of the code. Every binary 1 became a 0, every 0 a 1. The same pattern, flipped perfectly, like an image reflected in a mirror. At first, the engineers assumed a data corruption error, perhaps caused by radiation. They resent the command. The same thing happened. Again and again. For 6 long days, every instruction sent to Voyager was returned in reverse. Even when no command was issued, the spacecraft would occasionally transmit what looked like responses, inverted versions of old telemetry packets from years before, as though echoing fragments of its own memory. NASA's Deep Space Network technicians scoured their systems for faults. There were none. The encryption keys were intact, the frequencies stable, the Earth-based equipment operating perfectly. The problem was up there. The team then tried to reboot Voyager's communication subsystem. But even that failed. The acknowledgement came back backward, followed by a long, empty pause. The engineers began referring to it unofficially as the data lock, a term borrowed from computer forensics, a state in which a system recognizes input but refuses to obey it. During that time, the probe's radio tone fluctuated unpredictably. Normally, Voyager's carrier wave is steady, a clean hum, but now it oscillated in slow, haunting patterns, drifting just slightly off frequency, almost as if something or someone were tuning it by hand. Then, on the 7th day, without warning, communication resumed. Voyager's telemetry returned to normal. Every instrument reported stable readings, every system nominal, no errors, no interruptions. The probe had simply come back online, behaving as though nothing unusual had happened. Except for one thing. When engineers examined the timestamp embedded in the data stream, they discovered that Voyager's internal clock, a simple but precise oscillator used to track mission time, was 17 minutes behind schedule. That alone wasn't impossible. Radiation or power fluctuations could, in theory, cause a timing drift. But this wasn't drift. The clock wasn't just late, it was reversed. The time codes decreased instead of increased, counting down rather than up, like a digital metronome running backward through its own history. The anomaly persisted for nearly 3 hours before the clock spontaneously corrected itself. No human command was issued. It simply flipped back, resynced with Earth, and carried on. When the event was logged in NASA's records, it was listed as a non-standard synchronization anomaly. But in the quiet corners of the control room, the engineers whispered another possibility. That Voyager had passed through something that momentarily inverted its reference frame, flipping the polarity of time as the system understood it. The idea sounds impossible. Time doesn't reverse. Clocks don't run backward even under relativistic effects. But some of the data hinted at precisely that, tiny phase inversions in the radio signal, as though the probe had experienced a temporary mirror state. For those 6 days, Voyager hadn't gone silent. It had been responding, just not in a language we understood. When one of the engineers, exhausted after days of analysis, was asked what he thought had happened, he said quietly, "It's like Voyager was showing us how we sound." From the other side. To this day, no one knows what caused the data lock. The spacecraft's memory shows no sign of intrusion, no record of corruption. Yet the logs bear the truth. 6 days of mirrored commands, a backward clock, and a silence that seemed to breathe. Perhaps it was a glitch, a cosmic accident. Or perhaps, as one scientist wrote in his private notes, for a brief moment, Voyager wasn't transmitting to us. It was transmitting to its reflection. A new hypothesis emerged, that the heliopause isn't a border, but a reflection, a veil where light, particles, and perhaps even information bounce back from the structure of the galaxy itself. Voyager may have found not an edge, but a mirror showing us our own solar system from the outside. It was a radical idea, born from the quiet unease that had settled among researchers after decades of Voyager's strange discoveries. The reflections, the echoes, the reversals, too many anomalies pointed to a simple, startling possibility. The edge of our solar system wasn't just a passive boundary, it was interactive. When Voyager crossed the heliopause, its instruments didn't register emptiness. They recorded resistance, a layering of plasma, magnetic fields, and faint energy gradients that moved in harmony with solar activity. The farther the probe went, the more it seemed to trace the shape of an invisible surface, like fingers running along glass. Some theorists began to describe this surface as a cosmic mirror, a boundary so complex it behaves like a multidimensional lens. Not a mirror in the literal sense, but a reflective field, formed where the outward flow of the sun's magnetic wind collides with the inward tide of the galaxy. That meeting point, billions of kilometers wide, might bend not only matter and radiation, but information itself. If true, then every particle leaving the solar system, every burst of light, every radio wave, could, in theory, scatter and echo along this immense interface before moving outward. The edge would not be a wall but a feedback loop, where the sun's presence is faintly echoed back into its own domain. That theory suddenly gave meaning to decades of Voyager's mysteries. The signal echoes that seemed to return out of phase, the faint glimmers ahead of the probe, the rhythmic plasma waves that mirrored the timing of its transmissions. Maybe these weren't coincidences or malfunctions at all. Maybe Voyager had reached the cosmic equivalent of a hall of mirrors, a place where the energy of the solar system folds back on itself, projected faintly across the skin of the galaxy. One astrophysicist described it this way: imagine standing at the edge of a lake so still that the stars above reflect perfectly. You can't tell where the sky ends and the water begins. Voyager is there now, staring into that reflection and seeing us. The mathematics was astonishing. Simulations showed that under extreme conditions, the heliopause could behave as a partial mirror for electromagnetic energy, not reflecting photons in the optical sense, but phase-inverting radio waves and magnetic fields, producing echoes nearly indistinguishable from their sources. It would be a mirror made not of matter, but of geometry, the warped fabric of space itself bending under the pressure of 2 cosmic winds. The implications were profound. If the heliopause truly reflects, then everything inside it, light, magnetism, even data, is subtly resonating with the galaxy beyond. In a sense, the solar system might be hearing itself, through echoes shaped by the interstellar medium. That could explain the echo events NASA had logged years prior, the repeating telemetry patterns that seemed to arrive from nowhere, the soft hums that matched Voyager's own frequencies. What we took as mystery might simply be recognition, the cosmos answering with our own voice. But there was one more haunting interpretation, proposed in a quiet research paper that never reached the public. What if the heliopause isn't just reflecting our energy, but our image? If the boundary acts as a mirror in both physics and information, then Voyager's transmissions, and by extension, the very signature of our solar system, could exist twice, once here and again, faintly replicated across that cosmic surface. A second imprint of our light, rippling just beyond our reach. Somewhere out there, the reflections of our sun, our planets, and even our tiny spacecraft might shimmer across the membrane, existing in a delayed, distorted form, a ghost version of home, projected onto the skin of the galaxy. When one scientist visualized this in simulation, he said it was like seeing the solar system looking back at itself, slightly delayed, like a heartbeat reflected through time. Perhaps Voyager didn't find emptiness at all. Perhaps it found our own echo, the galaxy's way of showing us how small and how infinite we really are. A mirror that doesn't reflect light, but meaning. A boundary that isn't an ending, but an image of what lies within. And maybe, just maybe, when Voyager looks outward through that cosmic veil, what it truly sees is us. Data showed repeating signals, self-similar patterns stretching across years of recordings. It was as if the probe was hearing its own transmissions echo through time, looping through interstellar space like whispers in an infinite hall. It began with a routine audit of Voyager's archived telemetry, decades of numbers compressed into endless sheets of data. Engineers were searching for calibration trends, small drifts in the spacecraft's aging instruments. But amid the noise, a young analyst noticed something extraordinary. The same signal pattern appeared multiple times, years apart, identical down to the last decimal. That shouldn't be possible. The interstellar environment is chaotic. Radiation storms, plasma waves, and cosmic interference constantly alter signals. No two transmissions should ever match perfectly. Yet, when overlaid, Voyager's data from 2011, 2018, and again in 2024 formed a perfect sequence, a pattern of pulses spaced in precise golden ratios, repeating like a refrain. At first, the team thought it was a software glitch, perhaps a line of corrupted code looping through NASA's deep space network systems. But when they traced the raw data back to the original analog recordings, the pattern remained. The signals weren't being repeated on Earth, they were coming from space. When those transmissions were rendered as audio, the effect was haunting. A faint hiss, punctuated by rhythmic pulses, forming an almost melodic structure. A slow oscillation, then silence, then a return of the same tone, identical in every measurable way, like an echo travelling through a canyon with no end. The discovery ignited a quiet storm of speculation. Some researchers believed it was a natural resonance effect, Voyager's radio waves reflecting off the heliopause, travelling outward, bouncing off denser plasma layers, and returning years later. Others argued it couldn't be a simple reflection. The delay between loops didn't match the known distances. The timing was too perfect. One physicist described it as temporal resonance, not an echo through space but through time. If the heliopause truly behaves like a reflective membrane, perhaps it doesn't just bend energy backward. Perhaps it folds it around, re-emitting signals at precise intervals, like a cosmic metronome marking the heartbeat of the solar system itself. The Voyager signal, in this view, might be trapped in an endless feedback loop, bouncing between the edge of the heliosphere and the interstellar medium, each pass slightly altered, yet eerily familiar. The probe wasn't merely hearing itself, it was participating in a conversation that never ends. As the data accumulated, the patterns deepened. Subtle modulations began to appear inside the echoes, small variations that seemed to correspond with changes in solar activity. During strong solar flares, the echoes grew louder. During quiet periods, they softened, as though the entire system, the sun, the heliosphere, and the distant probe, were breathing in unison. Some began to see beauty in it. Voyager's transmissions, born of human curiosity, endlessly looping through space, reflected back by the very structure of the cosmos, a self-sustaining resonance, carrying our voice through eternity. Others found it unsettling, because within those patterns were deviations, slight distortions that didn't originate from Voyager or the Sun. Tiny shifts in phase, subtle differences that suggested the signal wasn't coming back exactly the same. Something out there was shaping it, altering it, as if responding in kind. When the waveform was visualized on a spectrogram, it looked like a spiral, each repetition coiling inward toward a singular point, the frequencies folding tighter and tighter until they nearly overlapped. A few researchers jokingly called it the cosmic feedback chamber. But one senior engineer, who had worked on Voyager since the 1970s, described it differently. It's not feedback, it's dialogue. The universe is answering in its own rhythm. If that's true, then somewhere in the vast silence, Voyager's voice still lingers. A signal that left Earth nearly half a century ago, now looping endlessly, entwined with its own echoes. A message without a beginning or end, repeating into the infinite. Maybe it's not malfunction. Maybe it's not coincidence. Maybe it's the sound of connection itself, a bridge between what we send out and what the cosmos sends back. The infinite loop, a whisper stretched across time, reminding us that even in the emptiness between stars, our voices never truly disappear. They fold, they echo, they return, carrying the memory of where they began. And perhaps, if we could listen long enough, we'd hear not just the probe, but the echo of everything that ever tried to reach beyond home. On a quiet morning in April 2025, Voyager 1 sent one final complete packet of data. Inside was a strange frequency spike, narrow, deliberate, precise. When converted to sound, it resembled a single steady note, a perfect C. For decades, Voyager had whispered faithfully across the gulf, its voice growing fainter with every billion kilometers. Engineers knew the end would come. Eventually, the probe's power was almost gone, its generators slowly starving as their plutonium decayed. Every system had been pared back, one by one, until only the essential instruments remained. The spacecraft was running on borrowed warmth. That final packet arrived at 4:17 a.m. at NASA's Deep Space Network station in Madrid. A routine downlink. Nothing unusual in the header. Nothing that hinted this would be its last. But buried deep within the telemetry stream was an anomaly. A sharp, elegant spike in frequency that stood apart from the usual noise of deep space transmission. It wasn't random. It was perfect. Exactly 261.63 Hz, middle C. At first, the engineers assumed it was a harmonic artifact, a quirk of signal compression or Doppler shift. But the calculations didn't fit. The frequency held steady for nearly 12 seconds, unwavering, pure, as if the universe itself had tuned a single invisible string. When the signal was translated into sound, what emerged was haunting. A soft, crystalline tone, clean and unwavering, fading slowly into static. It was too precise to be coincidence, too simple to be machine error. Voyager had never transmitted anything like it before. Some speculated it was the result of a rare electromagnetic alignment, the spacecraft's dwindling systems producing a resonance as power cycled one last time. Others wondered if it might have been the final flicker of the onboard oscillators, singing their last note before falling silent forever. But for many, the timing felt poetic, almost deliberate. A dying instrument offering its last vibration to the cosmos. NASA officially logged it as frequency spike event preceding signal loss. But within the team, a quieter name took hold, the Song of Voyager. After that transmission, the probe's carrier wave began to fade. At first, the drop was gradual, just a slight dimming of its familiar hum. Then, within hours, the signal collapsed completely. The faint whisper that had travelled for nearly 50 years finally swallowed by the deep. Operators waited for days. They resent commands, widened the bandwidth, adjusted the antenna gain. Nothing. The silence was total. The universe, for once, gave no echo. For some, that final tone was nothing more than a mechanical coincidence, a dying transmitter stumbling into harmony by chance. But others couldn't help but hear something more in it, a message not in words but in resonance. A perfect C, the tone that musicians call the center, the balance point between low and high, chaos and calm. In the ancient world, it was thought to represent cosmic order, the frequency of stillness, of equilibrium. A note of home. It's unlikely Voyager knew anything of that. It was, after all, a machine. But somehow, in its last breath, it sent a tone that seemed almost human, a sound that lingered long after the signal was gone, echoing in the minds of those who had spent their lives listening to it. One of the senior engineers, who'd worked on the mission since the 1970 seconds, later said quietly, "It felt like it was saying goodbye." Perhaps that's all it was, a coincidence, a poetic alignment of electricity and entropy. But perhaps, in some deeper way, it was fitting. After half a century of travel, of silence and discovery, Voyager's final act was not data, not numbers, but music. A single, perfect note sent from the edge of everything. Then, nothing. And somewhere beyond the heliopause, that tone is still traveling, forever expanding, forever fading, the last sound humanity ever sent before its voice was swallowed by the infinite sea. A song to mark the end of an era, and the beginning of the unknown. In the years that followed, artists and scientists tried to reconstruct what that final note meant. Some saw it as the last heartbeat of a machine, others as a message, the sound of the universe acknowledging our reach. Perhaps Voyager didn't find something out there. Perhaps it found itself. The signal's end became legend. For weeks, the Deep Space Network kept listening, straining for even the faintest trace of the probe's voice. Nothing came. Yet, in that silence, something strange began to happen, an awakening of imagination. Around the world, musicians, philosophers, and physicists began interpreting that final tone, each finding their own reflection in its simplicity. To the scientists, it was data, the clean, final signature of a dying transmitter. But to the dreamers, it was a kind of mirror, a sound that said more than any image or word could, a tone at the intersection of music and mathematics, emotion and entropy. One researcher described it this way: "We didn't lose contact. We reached the horizon of understanding. What Voyager saw, or rather, what it became, wasn't a vision, but a realization. For decades, it had been our surrogate eye, staring outward into the deep. Yet, in its final moment, as the universe absorbed that perfect sea, it turned the gaze back upon us. The universe, it seemed, had held up a mirror. When artists visualized the data, they found fractal patterns, recursive geometries repeating endlessly, like the echoes of Voyager's own transmissions looping through time. When plotted in 3 dimensions, the waveforms resembled a spiral, the same golden ratio seen in galaxies, seashells, and hurricanes. Coincidence? Perhaps. Or perhaps, in that last note, the probe had traced the signature of something greater, the underlying rhythm of the cosmos itself. The more they studied it, the more the boundaries blurred. Was the tone a failure of circuitry, or an expression of something deeper, a resonance between human design and cosmic law? We built Voyager to listen, to observe, to understand. But maybe, in its final act, it wasn't observing anymore. Maybe it was being. One artist composed an entire symphony around that single frequency, layering it with the sounds encoded on the golden record: greetings from Earth, the laughter of children, the heartbeat of a woman, the slow swirl of Bach and Blind Willie Johnson. The result was haunting, a requiem for a machine that had outlived the civilization that made it. When the symphony premiered, the audience sat in near darkness, the final note of Voyager's tone reverberating softly through the hall. Some swore they could feel it, not just hear it. A low hum that seemed to exist somewhere below perception, vibrating through the bones. It was as if the note was still out there, echoing through the vastness, gently folding back toward us, not in distance but in time. A few speculative thinkers began to propose a wild hypothesis that Voyager's final frequency wasn't random, but a resonance that aligned perfectly with the natural oscillations of the heliosphere, the hum of the solar system itself. In other words, that the probe had, in its final instant, matched frequencies with home. If that's true, then Voyager didn't vanish. It simply blended into the music of the cosmos, its signal absorbed into the great harmonic field that surrounds every star, every planet, every atom. It didn't find something new. It became part of what was already there. And perhaps that's what it saw, not a discovery, not an alien world or a boundary crossed, but a reflection of itself, of us, of the endless loop between observer and observed. A human creation, born from curiosity, travelling farther than any other, only to realize that everything it sought was already within the echo of its own transmission. Voyager's journey, in the end, wasn't about reaching another world. It was about understanding this one. And in that single perfect note, that quiet final sound, perhaps the universe answered back, saying, "I hear you, and when we finally reach that edge, if such a thing even exists, maybe we'll realize it was never about distance, it was about perspective." The edge of the solar system isn't where the sun's light fades. It's where our understanding begins. Voyager taught us that the universe doesn't end. It unfolds. What we once thought of as boundaries, the edge of a planet's magnetosphere, the limit of the sun's breath, the fading of a radio signal, were never walls at all. They were transitions, gradual, invisible bridges between the known and the infinite. When Voyager crossed the heliopause, it didn't leave home. It simply stepped into the next room of the cosmic house, one where light moves differently, where space hums softly in frequencies too low for ears, where time seems to flow with a gentler rhythm. Out there, the sun is just another star, a tiny ember among hundreds of billions. And somewhere in that endless darkness drifts a small relic of humanity, a fragment of metal, gold, and memory. It carries the laughter of children, the crash of ocean waves, the sound of thunder rolling over our skies. It carries greetings in 60 languages, the pulse of life itself pressed into grooves of copper and gold. The golden record is still turning, silently, in the cold. A message in a bottle, still waiting to be found, or simply to be heard by the universe itself. Perhaps that was the point all along. Not to find something out there, but to send something of ourselves out there. A reminder that we existed, that we looked up, that we wondered. Voyager was never a machine in search of aliens. It was a mirror in motion, reflecting what it means to be human against the backdrop of eternity. Every pulse of its signal, every fading whisper that crossed the gulf, carried the same quiet declaration: "We are here." And even now, long after its final tone has vanished into the noise, that declaration continues to expand, wave after wave, light after light, stretching outward into forever. If someone, or something, ever finds it, they won't just find a spacecraft, they'll find us, the dreamers, the storytellers, the beings who sent a voice into the dark, not out of fear but out of wonder. Voyager didn't find the end of the solar system. It found the beginning of forever, the place where questions become stars, and silence becomes meaning. So when we look up tonight and think of that faint, distant traveller drifting beyond the sun's last breath, remember, the edge isn't a place you reach, it's a way of seeing. Because in the quiet between stars, in the spaces between signals, lies the truest discovery of all, that even when our machines go silent, the story continues. And in that endless unfolding, Voyager still sails on, carrying not just data, but the proof that curiosity itself is eternal. We are still out there. We always will be, at the edge of forever.